Ladies and gentlemen, before we start the next sessions, let us see the video profile of Jakarta Technical University of Fisheries.
And envisions to become the leader in the Fisheries University is Indonesia's oldest vocational education focusing on fisheries sectors that aims to develop marine and fisheries human resource and envisions to become the leading center for marine and fisheries vocational education in Asian region. The Fishing Technology Study Program educates cadets in navigation systems, fishing gear design and maintenance and mastery of the latest fishing technology. The Fisheries Engineering Study Program aims to educate cadets with analytical abilities in the application of fisheries engineering skills and knowledge and focuses on developing expertise in engine room management. The Fisheries Product Processing Technology Study Program is designed to produce graduates who master, develop, and apply post-harvest technology which includes handling, preservation, and processing of fishery products while demonstrating an in-depth knowledge and understanding of fisheries product quality requirements to meet both domestic and international criteria. The Aquaculture Technology Study Program is designed to produce human resources who have high competence in mastering the science and technology of aquaculture to maximize the potential of aquaculture. The Technology Study Program aquatic resources produces graduates who have the knowledge and skills to study potential, plan utilization concepts, formulate utilization status, and evaluate water resources management both at the operational and institutional levels. The Fisheries Extension Study Program is designed to produce professional and competent extension experts who are capable to manage fisheries extension activities effectively based on communication technology in order to improve the competitiveness of fishery products. Jalanidita Sarva Jivitam. Upholding the motto Jalanidita Sarva Jivitam, which means sea is the source of life, the Fisheries University continues to excel in utilizing sea resources as God's gift for the sovereignty, sustainability, and prosperity of the Indonesian people.
The Excellencies, the expert speakers, and distinguished guests, we are now going to the next session, which is the opening remark. And before that, I would like to inform that this webinar is also live on YouTube of Jakarta Technical University of Fisheries. First, the opening speech will be delivered by National Chief Technical Advisor of Global Quality and Standard Program Indonesia Smart Fish. Please welcome Mr. Sudari.
Thank you, Afi. Ladies and gentlemen, good afternoon, everybody. Assalamualaikum warahmatullahi wabarakatuh. To distinguished speakers and also participants, first let me introduce that my name is Sudari. I am the Chief Technical Advisor of the UNIDO program called Global Quality and Standard Program, a program that is funded by a Swiss government. So, first of all, let me thank also and congratulate Pak and also colleagues from the Polytechnic of AQUA or Jakarta Technical Fisheries University, as well as Professor Mike Dillon for organizing this webinar. And on behalf of UNIDO GQSP Indonesia Smart Fish 2, we consider this topic of this webinar is very timely, and it is in line with the government priority for developing aquaculture in Indonesia. And also congratulations and thanks also to the distinguished speakers who are well-known expert in the field of aquaculture and productivity, namely Dr. A.T. Ramachandran Naik from College of Fisheries of Mangalore. Welcome to Indonesia, though this is virtually. Also Krishna Salin, PhD from ASEAN Institute of Technology, Thailand. Professor Dr. S.T. Hardy, MSI from Mulawarman University, and also Dr. Romi Nofriadi, MSc from the Ministry of Fisheries, Ministry of Marine Affairs and Fisheries, and and also all the guests and also participants. I'd like to share a few slides for my speech. I think that I have probably Afi or the organizing committee can share that slide I shared earlier. I have a few slides just to introduce Wika. Can you send the slide, please? Or shall I share it from my side?
It's up to you.
Okay. Okay. Just to share with all the participants on our program. Global Quality and Standard Program is a UNIDO funded by Swiss government program, and this program actually is involving 8 countries currently, and then in different continents. And we are the global. The program is involving 14 value chain, and then also currently 8 countries involved in this program. And for Indonesia, we call this program at GQSP Indonesia Smart Fish 2, that is running from 2019 up to 2022. This is actually the extension of the previous program, that's Smart Fish Phase 1. Then we are focusing mainly on aquaculture value chain. We are now working on 5 value chain, namely shrimp, seaweed, pangasius, milkfish, as well as Clarias catfish. In our program, we have 3 main outcomes. That is to strengthen the national quality infrastructure. And the second outcome is to strengthen or to have the SME to comply with standard and technical regulation. And then we also have a program together with the Minister of Fisheries to improve the quality awareness, to build up upon the quality culture among stakeholders. The main objective on this of this program actually is to help the Minister of Fisheries, particularly in the aquaculture sector, this 5 value chain, to improve the competitiveness, sustainability, also for the prosperity of the stakeholders, in particular for the farmers. Of course, our program is just a small program. This is kind of seed to help the government of Indonesia to transform the aquaculture into the sector that is competitive, whether is it in the domestic market or international market. And of course, we also consider that the sector must be sustainable and create for prosperity or value to the income of the stakeholders. A lot actually to transform the aquaculture. We understand there are a lot of actors, a lot of factors that is working in this environment, and then we realize that there are a lot of conditions needed to transform this sector, and our program is a small part of it, and we hope we can work with all the actors, all the stakeholders to transform the aquaculture of Indonesia. Using a theory of change, actually we identify a condition to transform this aquaculture into more productive, more competitive, and also to improve the sustainability of the sector. And then we identify also 5 main domains, that is on governance, finance, markets, knowledge and innovation, and production. Today's seminar is very relevant, in particular in terms of knowledge and innovation, as well as to improve the productivity of aquaculture. And we will learn from India, from speaker from India, also from Thailand, from Mike Dillon, as well as from national speakers today, how important is it the innovation, the technology to improve the productivity of the sector. And we are willing, or we are ready to work with other stakeholders, with the government, to transform this aquaculture into more productive and more competitive sector. I think this is what I would like to say, and then thank you again for all the participants, all the speakers, and as well as the Polytechnic for organizing this very good webinar. Hopefully this will bring a change to the aquaculture sector into more productive and sustainable sector. Thank you very much.
Thank you, Mr. Sudari. The next speech will be delivered by Professor Michael Dillon as the Chair of the World Confederations of Productivity Science and CEO of Institute of Productivity. Ladies and gentlemen, please welcome Professor Michael Dillon.
Okay, so first, my congratulations to the Jakarta Fishery University for organising. I know how difficult it is to bring 150 people, 200, 300 people together at one time. My thanks to Dr. Ramachandra and Dr. Salin, who I asked to take part. For me, I give my regards from IAFE, which is the International Organization on Seafood Inspection and Trade, where I am Secretary General. I think it's useful that we share information worldwide on the fishery sector, and this meeting will be circulated worldwide to the different sectors through the Fish Inspector, where we'll write a short article on the event. I send my regards to Dr. Ramachandra in terms of actually as another institute like JFU and to AIT. My own fishery institute in Grimsby, we are formed in 1943. So we're very interested in sharing ideas between institutes. Today, I want to look at smart aquaculture, smart fishery, and how we improve performance. As Sudari has said, I am well, for me, 30 years working with UNIDO on different projects. So interesting to see what other countries actually do. Can I have the next slide, please? Okay. This is a slide from 2005 when we began to build. I had my own a smart factory where we started to look at how we could make different pieces of equipment speak to each other. This is a ScanVec system. That was an investment of $100,000 to actually connect everything. Next slide. Next slide. Okay. In the same area, we have 5,000 small and big fish factories in our area where most of the information is captured by hand and then sent in from a computer to actually log data. And that will be the same still in many, many places in Indonesia, that we still use a written documents and capture data in a handwritten a form. Next slide. Okay. When we actually then begin to bring in scanning devices, machine reading devices, automatic reconciliation, we begin to improve the performance of the business, and we begin to improve the ability to increase productivity within the factory, and we begin to increase the ability of the business to manage the information that it uses. We did this work because Walmart had said in 2005 that all the top 100 businesses supplying Walmart had to have RFID devices in place if they wanted to supply their business. And at that time, we worked closely with Walmart as a demonstration center to put in what was new technology 15 years back. Next slide. Next slide. Yeah, okay. Now you see what happens when we integrate all of the different units, from scales, printers, labelers, probes gathering data on the information of the product as it moves through the factory. We suddenly have a factory that can speak. So 15 years ago, in terms of smart technology, we radically improved the productivity and the performance within the factory businesses, because we could actually immediately see how well the factory performed. But this is an aquaculture presentation. So let's look next at what happens in aquaculture. Next slide. So this is the seamings. This is the technology system, looking now at how you control information from feed, how you can control information from aquaculture on land, how you control aquaculture at the sea, right through to the end of the process, where you can gather the information during the slaughtering and processing of fish. And I think their estimate would be something like a 20% gain in productivity on an already advanced manufacturing sector who are already integrated. So if you're a well-organized fish processing factory, you want to integrate with the farming side, you would expect to get benefits. Next slide. Okay, so now we're at the automated plant control for making sure that fish feed is actually provided and managed, and you're actually controlling the water quality actually in the aquaculture unit. Next slide. Next slide. Yeah. Now we're looking at sensor technology. You're actually looking at the water quality and their oxygen, pH and temperature. There's a water analysis system fully integrated. In 1985, I began building sensors at that time for rapid detection of different things using immobilized enzymes. So I've been involved in sensor analysis for the last 35 years. So I think it's rapid detection, information that you can use quickly is key for Indonesia in terms of how it improves performance. Next slide. Now you've actually got a complete overview of the entire farm. You've actually got a feed control, energy, water, remote control on mobile phone. So this is great for big business. It's wonderful to look at Siemens in a large integrated aquaculture unit. But this is relevant for the top industry in Indonesia in aquaculture. Let's look at the next slide. However, many farms are small businesses. This is an Australian oyster farm. It developed its own smart app. There are many clever people in Indonesia. You know, they developed a simple a system that allowed them to manage all of the activities within the farm. And again, they've actually controlled this from their house rather than being on the farm. They can actually collect the data remotely, better control, better productivity, better profit. And again, you know, I say I was asked to review the World Bank project in Bangladesh, which is tens of thousands of fish farms. We're working with UNIDO in Pakistan in World Bank project formulation. And I would estimate a minimum 300 to 500% gain in performance from a traditional farm if they start to move towards a intensive farm in terms of productivity, but it needs to be controlled. So these new simple apps developed by the country itself should enable a aquaculture businesses and the extension service in the country to start to look at how they improve performance in small aquaculture units. Next slide. Yeah, it just means that you're gathering the information right through the supply chain using a handheld device linked to different types of information on the chain. Next slide. Next slide. Okay, now I talk a little bit about robotics. This is a laser firing device that kills lice through laser beams in salmon cages. This is Stingray is the robot. It's been running for about 4 years. It reduces mortality, increases productivity, increases the profitability because it actually manages the disease or the pest on the fish. It's already fired about 1 billion laser beam shots to reduce lice in salmon cages. And it's not a dream, it's a reality. I think we need to dream big in terms of technology that can help what we do. Next slide. Now this is digitalization, when we actually look at how we use digital technology. So I'm interested in digital marketing, digital sales, as well as the activity which occurs in the business. Next slide. So we need to look at digital practices. We've looked at the farm, we've looked at the sea. The challenge from COVID meant that we needed to look at remote inspection systems to confirm that our supply chain, when we export products, is in control. So for aquaculture, it's good to actually be able to inspect the farm from Jakarta rather than actually visiting farm. Next slide. So we organised a series of webinars with the government and with UNIDO, where 600 inspectors took part in looking at workshops on how we could monitor different information and capture this using smart technology. Next slide. So with the COVID outbreak, we looked at what America did with FDA. We looked at what UK was doing. We looked at what Australia did. Pasadari helped coordinate what we were saying and what we looked at. So we had 4 webinars on remote inspection, and there's a working group with the government feeding back on the policy from this, okay? So COVID outbreak, site inspections, Zoom activity, how we could gather the information and analyze. Next slide. So we set up remote audits, we set up inspection check sheets, we looked at COVID control, and we captured pictures, questions, notes, recordings, all done by Zoom, all done by integrated systems, which ensured that digital and smart technology allowed the government to ensure that it had adequate control for export. Next slide. So, what are the digital skills? I'm interested in Dr. Ramachandra's a presentation on skill, because I think these new skills, using device, handling information, communication, transacting activity online, all of these things are increasingly important to small aquaculture business. So, next slide. Okay, so for businesses that sell online using web-based systems, sales and marketing, if you supply to retail, you lose 40%. So if you sell at $1, 40 cents goes to the retailer. If you go through distributor wants 20%, so you lose 52%. If you can go online and actually you sell your product direct, which COVID has forced many fish businesses to do, they make more money. Okay, so it's increasingly important that businesses understand smart systems for selling product. Next slide. Yeah. Okay, this just gives you need to position and look at where your business is. You can use Google Analytics. You can gather important information about who works on your site. These slides are there for everyone, so I'm not going through every point. This is an overview for the speakers that come next. Next slide. Now, what content do you want to put on? I still have a small business. We sell about $500,000 per year online. It's important that you put the right content on the system. So the stories which you tell about catfish from your country, or seaweed, or milkfish, or shrimp, those are important because the consumer wants to know that you've got control. Next slide. Social media, actually using Instagram, actually having different platforms like Facebook or Twitter or YouTube, where you can tell your stories, is important for your sales and for the profile of your country. Next slide. So I have another business that's been set up called Seaweed A Go-Go, specifically on seaweed. We are manufacturing and positioning to the retail sector, different seaweed-based products. We're looking at demographics from users, how many site visitors. So you need to actually understand the power of the internet. Next slide. Okay. So this was an introduction or a platform for Dr. Ramachandra, who will talk about skill, for Esty, who will talk about smart technology, for Dr. Salen, who like me might talk about smart systems. So IoT is growing all the time. Smart aquaculture's here, apps are here, connectivity is here, sensor and robots are increasing yearly. As I said, it should improve productivity of a good business, I hope, by 20%. Informal sector, you know, I've spent 30 years in different countries. I think a small a business can increase a lot. 500% is not unusual. Digital skills needed in the new world for more profit. And I think for me, I asked for this event and discussed with Dr. Sidari and Dr. Ilham that we should look to join hands with other institutes worldwide to form research networks to share information. So many projects running in different countries, we don't see the information. So it would be really good to see the information from India, to see the information from AIT. I want to bring the information from Bangladesh, from the other World Bank projects so that they have the opportunity to share. And if we want to see best performing pangasius, Bangladesh and Vietnam are good places to share information with. So I leave everyone with a good morning again. I'm looking forward to hearing Ilham share a view from Jakarta Fishery Institutes and the other speakers share information. Any information which participants want from me, they can get through a ICA or her team at GFU or Pasadari at UNIDO with whom I work. So I wish you all a good morning. I know it's difficult when we have short time to share ideas, but I hope the presentation this morning was useful for you. Thank you again to the organisers, thanks to Pasadari and to the group that are speaking this morning. Thank you.
You are muted, Dr. ST.
Thank you, Prof, for the great overview presentations. And ladies and gentlemen, next, we're going to listen the opening speech delivered by Mr. Ilham PhD as Director of Jakarta Technical University of Fisheries. And also, we would like to request our Director to officially open the international webinar Smart Aquaculture and Productivity. Please welcome Mr. Ilham.
Thank you, Afi. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and good afternoon, ladies and gentlemen. First of all, I would like to welcome my colleagues from the UK, Professor Mike. Thanks for joining us. I know it's too early for you today. I guess still 6-something in the UK now. And then Dr. Ramachandran from College of Fisheries, Mangalore, Dr. Salin from Asian Institute of Technology in Bangkok, Thailand. Also, our other special guests today, Professor ST and Dr. Romi. Professor ST is from the Mula Warman University, and Dr. Romi is from the G of Aquaculture, Ministry of Marine Affairs and Fisheries. Also, thank you, Dr. Sudari from UNIDO for your availability in time today. Ladies and gentlemen, first of all, let's thank God for all His mercies and blessings given to us so that we can virtually attend this session today, attending the virtual seminar titled Smart Aquaculture and Productivity. Next slide, please. I would like first to introduce a bit about the Jakarta Technical University of Fisheries, formerly known as Jakarta Fisheries University. Recently, we have 7 study programs, running 6 applied bachelor degree programs and 1 applied master degree programs. We are a vocational higher educational institution in Indonesia, and we are the only one institute who are running this program. Yes, we were actually established in 1962, and then just this year we became polytechnics in 2020. We have around 350 staffs, consisting of 100 lecturers, around 150 academic staffs, and more or less about 100 non-permanent staffs. We also have 2 research vessels. One is, I think, the biggest research vessel in marine fisheries research vessel in Asia, with 760 gross tonnage. Currently, we accommodate about 1,500 bachelor degree students, and around 84, almost 100 postgraduate students. We have 3 campuses. Our main campus is located in the capital of Indonesia, in Jakarta, and we have 2 other campuses located in Bogor, West Java, and one in Karangantu, Serang, Banten province. Next, please. This is our vision to bring the university to be the top 10 polytechnics in Indonesia within the next 5 years. This is our big hope, and I am actually just appointed as the director of the university around 4 months ago. Next. Next, please. Yes, next. And next. Yeah, I think this is very important information for all of us, especially in Indonesia, that I got this data from the Indonesia NVO, National Productivity Organization. There are huge data and information published by the Indonesian Ministry of Manpower and the National Productivity Organization. One of the data is, appear in this slide. This data explains the productivity indicators, looking at the average income per salary, per net income per month of the people dealing with a range of sectors: agriculture, forest and fisheries, mining, processing industry, gas and electricity, water and waste management, construction, IT, finance and real estate, and blah, blah, blah. And of those sectors, fisheries, in addition to agriculture, is the least productive sectors. And this data also explains that the productivity of fisheries industries, including aquaculture industry, is very low. I think the lowest of all sectors, development sector in Indonesia. Next, please. And I think that it has been explained by Mike that one of the key things to improve productivity in the fishery and aquaculture sector is, to empower collaboration, to improve our partnership. So yeah, this is our pentahelix strategic partnership within the next 5 years, and we've been working with many organizations and universities, either nationally or internationally. Actually, at the moment, we have been working with AAT, for example, in which Dr. Salim is working for through an international project. Also, we've been working with Professor Mike with his IOP, Institute of Productivity in the UK. We've been working with UNIDO at national level. We've been working with Dr. Romi and team, and also happy to collaborate with Professor ST Professor ST, I have a very close friend at your university, Dr. Rudy. Dr. Rudy is my colleague when I was doing my PhD in Australia. And yes, I think the session today is very important for us to share information technology and innovation regarding how to improve our productivity in aquaculture. Next, please. Thank you very much. So in my capacity as the director of the Jakarta Technical University of Fisheries, and by saying Bismillahirrahmanirrahim, I would like to formally open the webinar titled Smart Aquaculture and Productivity. So Bismillahirrahmanirrahim. Thank you very much. And I would like to return this to Mbak Api. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Ilham. Waalaikumsalam warahmatullahi wabarakatuh. And before we go further, we would like to have photo sessions to the excellencies. Our international speakers as well as participants are welcome to take a position, and please turn your video on. Okay, so we will start with the first slide. 1, 2, 3. Okay. Next, second slide. Okay, wait. Okay, second slide. 1, 2, 3. Okay. Next slide. 1, 2, 3. Okay. Next slide. So we have 9 slides over here, but I think we will stop at 4th slide because no one turned on the video. Okay. Okay, so thank you. Now, we are now continuing to our main agenda. That is to hear the presentations, which will be delivered by our international expert speakers. And these presentations will be moderated by Mistress Fitriska. Mistress Fitriska, time is yours.
Okay, thank you, Afi. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Director of Jakarta Technical University of Fisheries, Mr. Ilham PhD, National Chief Technical Advisor, GQSP Indonesia Smart Fish 2, Mr. Sudadi Parwiro, and Chairman of the World Confederation of Productivity Science and also CEO of Institute of Productivity, Professor Mike Dillon. Thank you. Welcome. Ladies and gentlemen, so allow me to introduce myself. My name is Fitriska Hapsari. It is an honor for me to be your moderator in our international webinar with our theme for today is Smart Aquaculture and Productivity. So I am pleased to welcome all of our participants. This webinar is a collaboration between iPride for Fish, Jakarta Fisheries University, and Institute of Productivity. But before we start, actually, I saw one question for Professor Mike. Is it okay for you to answer the question, or we just continue? Okay. So there are one question from Dr. Umi Zakia. So her question is how and what should be the preparation for especially the human resource to face the technology, as perhaps have been acknowledged that Indonesia as one of the developing country at this stage that needs a lot of preparation in many ways, remote areas, internet connection, people skill and availability of the technology and people who operate them, etc. Professor Mike?
Okay, so first, the change question is always the key question. Okay, we often talk about technology, but in reality, the big issue is how do we change? So I think the work which Sudari has done on what I call simple standard operating procedures. Before you can change anything, you need to know where you are. The issue with many small businesses, and this for me has been for over 40 years of different projects, has always been about what is the existing baseline? Where do we actually stand now? How do the small businesses perform? And the answer is we don't know. Okay. So when we don't know what we don't know, you can't improve. Okay. So the first thing you need to do is you need to know what you don't know. And that means you need to speak to the small businesses in these different areas about what their performance is like, what challenges they face. So you get a landscape of what the issues are. So you need to learn to listen very carefully to the people in the communities in the areas where they produce the product, and then work with them on things that are culturally acceptable and actually make business sense for them, not in Jakarta, not in Glasgow, not in Medan, not in Bitung, but in the specific area where they operate. So Sudari gave a very good slide on change. But I'm a very simple guy, so I like, first we need to have a benchmark on a small, a traditional a fish farm might produce 200 kilo per acre. I think 10,000 farms we studied in Bangladesh, 200, 300 kilo for that particular shrimp species was the normal performance. To move them to maybe 800 kilo, which was also very small, there's a lot of things you need to do which are very simple on the farm, but you need to involve the community. So first, I think you need to understand locally what the conditions are with the group, which is the extension service role. But you also need to know what's possible. In the same farm, which was a 200 kilo per acre, you could achieve 5 ton. Okay, so you could get 5 ton per acre in the same farm. So you need to think it's not possible to go from 200 kilo to 5,000 kilo. What's sensible is maybe they go to 500 kilo. Yeah, and this is the technology that we can use. But simple apps, first of all, a code of practice, which is in pictures, not in writing, but something that the farmers can understand. It's linked to money and productivity, which the farmers can understand, not technical, not dissolved oxygen, not pH, not effluent content. These are the things that the small farm will understand. So you need to work in your extension service, knowing what the best practice is, but in very small steps, actually how you go there. Some people will jump. If you have an Ilham, you have a Celine, you have a Ramachandra type brain, or an AQUA, or an Este, there'll be some people who'll jump far, but most in the community will only go small step. So I think it's good that we share between the institutes. I think that's why it's interesting to see Ilham's list of institutes that he collaborates with in Vietnam. All of us have our own networks. What would be useful for the extension service is to understand that everyone has this problem. It's not unique to Indonesia. It's every single country that I work in. When I started in Canada 30 years ago, then very remote parts of Canada had no idea what other parts of Canada did. So it's the same. So it's the same. We don't know what we don't know. We need to know what we don't know. And then we need to share it and understand locally how we change. And it needs to be a sustainable change, something that can work, not because a project brings money, but because the local people can actually use the information and the skill to actually achieve better performance. My own view is that we need aquaculture technicians, maybe a 3-month training program where local community teams can be trained by the Extension Service and by JFU or the other institutes in the country, that they understand how they can monitor better and they can use better systems. In Bangladesh, I made this a Boy Scout badge. I made it a Boy Scout badge that if you wanted to run the farm better, you could achieve a Scout badge as a young farmer, a young fish farmer, or a young agricultural farmer, so that the farmers and their families understood that this wasn't something that you needed a degree to do. It was something that they could do themselves in a short course. And actually we distill all academics want PhDs and research papers. All communities want is simple COPs and profit. And we need to make sure that we do it. So I'm sorry if this has taken a few minutes, but I think it's a fundamental question for every institute, for every project that we've ever run, which is you need to start with what do the community and the farmers want, and then work from there, not to produce more research papers or more a PhD, but to help the local community compete. Okay, Aika, I pass it back.
Okay, thank you, Mike. So basically, we have to know the problem and then fix it, and what is the we have to know what is possible to do before. Okay, thank you, Mike. Is Dr. Rumi have a question? If not, we are continuing our session for today.
Now. Thank you.
Yes.
Thank you for this.
Okay.
For this guy. Yeah.
Thank you.
Thank you.
Yes, thank you. Well, maybe my name is not, it's too long, but you can call me Ika actually, but thank you.
Oh,
so
okay.
Let me just continue. Yes, let me continue. So ladies and gentlemen, so let me introduce our speaker of today. So we have for our first speaker is Mr. Krishna Salin. Mr. Krishna Salin is from PhD. He is the chairman of Aquaculture program in Asian Institute of Technology in Thailand, and then followed by Dr. Ramachandra from India. He is a professor and a nodal officer cum coordinator of the SDF STC College of Fisheries, Mangalore, India. The third, we have our only female speaker, Professor Dr. Esti Hardi from Indonesia. She is a lecturer from Mula Warman University. And last but not least, we have Dr. Romi Novriadi from Indonesia. He is a researcher from Directorate General of Aquaculture in Marine Affairs and Fisheries Ministry. And he also vice chairman of Indonesian Aquaculture Society. So, ladies and gentlemen, before we start this seminar, for each speaker, we'll have 15 minutes for their presentation, and there will be an answer and question session in each of presentation for only 10 minutes. So for those who are going to ask, you can drop your question in the chat column in the Zoom, or you can drop your question in the YouTube column comment, okay? So ladies and gentlemen, without further ado, I would like to welcome our first speaker, Mr. Krishna Salin, with his presentation titled Smart Aquaculture Technology, Enhancing Productivity and Quality. So Mr. Salin, the time is yours.
Thank you, Dr. Fitriska. And thank you, Mike, for inviting me for this presentation, and also the distinguished panelists. Dr. Ramachandra, Dr. Ilem, Dr. Sudari, Dr. Esti, Dr. Romi, all good friends, and distinguished delegates or participants for this webinar. Let me share my screen today. Okay, I hope you can see this. And yeah, I would try to present an overview of the smart aquaculture technologies which are prevalent. I might have added more because Every moment, that there are several new technologies and systems are emerging. And, most of these, as Mike and other speakers have mentioned in the opening, all these technologies and systems continue to improve the productivity and, of course, the quality of the product that we produce by aquaculture and also by capture fisheries. So we all know the challenges facing the global food system, particularly related to the hunger and poverty, owing to the increase in human population. And we are destined to target a very high increase in production of fish. You know that the global fish production is about nearly 180 million tons, and the aquaculture contributes just 82.1 million tons. And we are really targeting to produce at least 100 million tons in the next 5 years. And one good thing in this trend is that the overall percentage of aquatic plants and mollusks are increasing because they are very important for enhancing the production in terms of volume from our water resources. So looking at the technologies that can change the production and productivity, that we all need expect these technologies to have their impact on the entire global value chain, right from the inputs or supplies, production, processing infrastructure, marketing logistics, and also improving the quality and safety, which in an overall scenario leads to the sustainable production and consumption of seafood for human consumption. Looking at the early growth stages of aquaculture, that early growth stages witnessed very low awareness on the production or productivity, very low awareness on the environmental regulations. So it was a natural phase of growth. But as we entered into a intensification process aimed at improving productivity, we know that we wanted to stock high densities, we wanted to feed them highly efficient feeds, and we wanted to improve the productivity of the stocks in terms of genetic improvement and also the development of superior healthy stocks, at the same time improving the conditions where we grow them, improving the water quality, water recirculation, or the increased application of probiotics. And there have been consequent researchers, advanced researchers in nutrition and advanced researchers in the health and genetics technologies. So on top of all this improvement, the digital transformation that we are witnessing in this decade, which is in fact the core of all modern business strategies. We are at a stage where aquaculture is one of the fastest growing food production sector, but at the same time, the digital technology is the most rapidly advancing innovation in human history. So we really need to have a good integration of both these systems or technologies, to improve the current reach of digital technologies. For example, we have at least 50% of the global population have connection to the 50% of the population in the developing countries have connection to the digital technologies, but we need to have more reach, especially in transforming the societies, especially in enhancing the connectivity and also improving financial inclusion and access to trade and public services. So digital transformation, as many of the speakers have explained today, is not just having the ability to use internet, but it is growing to a stage where we need to have access skills, especially on the emerging cognitive technologies like the artificial intelligence, machine learning, and all those big buzzwords we talk about these days. So as an academic, when, as you know, the new disruptive global challenges in fact made us think of how to have a notable change in the academic sector, because we all dependent on a physically connected global education system, and with the campus, with the physical campus life as the core of its activities. But we realized that this is going to change, especially we had this virtual education for long, but we hadn't utilized their potential, and we realized that the pandemic has a big, uh, catalyzed the big need for a transition from physical to a virtual campus. And at AIT, we were really, innovative enough to make this transition quite fast, from a physical mode to a virtual hybrid mode of instruction. And in that process, we did not lose a single day of teaching or learning at the campus, with all our classrooms modified to virtual classrooms, with the facility for students to join physically. At the same time, online students can access the learning materials remotely. So this was a big digital transformation that we achieved in the teaching academia in AIT. Looking at the futuristic aquaculture technologies that we want to talk about to improve productivity, we have so many of these emerging, and I will just touch upon a few of them. Especially, we talk a lot about the IoTs and the sensors, which are actually revolutionizing the aquaculture systems. For example, this picture is a simple IoT device for the 3 water quality parameters: the pH, temperature, and dissolved oxygen, developed by our students, a collaboration of aquaculture students and also the students from ICT sector, the computer savvy students in AIT. So these technologies are really easy to grasp, and with all the open source platforms emerging, it becomes, or it is expected to become, a layman's technology in these days. And as the digital transformation grows into more expanding applications using the computer vision, imaging systems, and the greater interpretation of the images that are emerging in many parts of the world, in many production systems, in the case of many species cultured, and their applications have are increasingly expanding in these days. The combination of artificial intelligence and machine learning has in fact made much headway these days, with the technologies helping us for predictive analysis, data-driven decision making, counting to be more accurate, minimizing feed wastage, reducing the cost, preventing diseases, and also with so many other environmental applications. Here you can see the expert sea system, which is very popular, or getting very popular in hatcheries and other places, where you can easily and reliably count the larvae or post larvae. And another system I can highlight is a simple egg or larval or PL counter, which is now being tested in Thailand. Especially, it can precisely or more accurately count the egg number with the samples. So this is getting more popular these days. And going to the more applications, especially in feeding, because these days we have the systems to precisely program the feeding based on the behavior analysis of fish or shrimp, rather than just the appetite. And more accurate models are emerging, especially for salmon and also for shrimp. So this is a very positive outcome, and it's getting expanding on many different species. So more intelligent feeding systems, especially for salmon, you can see the systems. They almost precisely model the shrimp fish behavior, and the acoustic sensors for smart feeding. They have been tested in many farms, and many of these technologies, especially in Indonesia, you are mostly familiar with the e-fishery. So everywhere, this kind of technologies are expanding, and from ponds to more extensive areas in intensive culture. For example, the prediction of fish behavior in deep sea cages, like you can see the cage eye hydroacoustic sensor, which is being tested in the Norwegian cages these days. So these are some of the examples from the that help in feeding. And Mike showed the application of robots and remotely operated vehicles. And we see an increasing application of these kind of devices, especially in the cage farming, in the deep sea cage farming, because of so many factors, environmental factors and climatic factors, the operation of cages are sometimes difficult. So in those cases, we can use many of these remotely controlled vehicles or submersible can be used to observe the behavior of fish, maybe to clean the cages, precisely time the feeding, and so many other applications. Again, the 3D printing is another, increasingly emerging or popular system where you are able to 3D print several systems. One good example is the 3D ponics, where you can print an aquaponic system based on the design you make, based on the capacity you want. And again, applications of seaweed gels made from seaweed is currently being used or tested to print, medical implant devices. So that's a big application that can even, lead to the 3D printing of tissues and organs. So very interesting applications that follows. And 3D printing, you can see this robotic fish developed in MIT a few years ago. And this can be used for several underwater applications in ecosystem studies, environmental, observations, and many of these applications are yet to be known. And of course, the blockchain technology that we often talk about, its potential is more to be explored, especially in the supply chain in seafood. And we have one of the recent or initial startups like the fish coin that is getting popular, and blockchain has the ability to provide safe transactions among suppliers and purchasers, and several of its potentials are yet to be explored. So the future fish farms are going to be remotely operated with the need to not to have so much of human resources to be invested, but most of the designs will be based on unmanned operations, especially in the deep sea, and also to monitor the environmental parameters, environmental consequences of farming, and also to maintain the precise operating conditions of most of the species that we use in marine offshore cages. So with all these applications, especially with the integration of different trophic levels, especially in the marine systems, with the development of IMTA systems, many of these digital technologies are going to be more useful in utilizing the wide or extensive marine or inland areas that can be used for aquaculture. So before I close, let us look at some of the problems or challenges that we face. And this picture, you can see, it's a very interesting picture that emerged during the early days of pandemic this year. And you can see this is a picture from Kerala. Actually, It's my own province in the south of India. And Kerala, in fact, has some of the most well-developed human development indices, similar to many of the developed countries in the West and East. But even in the remote areas of Kerala, there have been issues with connectivity that forced this poor girl to get onto the rooftop. And this is another picture that is coming from our nearby state, Karnataka, and also from Kerala. You can see this is these pictures are clear, testament to the issues that we are going to face in many of the developing countries, especially in tackling the infrastructure systems that we have to build up. And looking at the aquaculture operations, this is a big challenge for many smallholder farmers, especially, smallholder farmers form nearly 80 to 90% of the global aquaculture operations. And how easy or how difficult is for the smallholder farmers to cope up with these challenges in digital transformation is yet to be known. It's difficult, and as we can see, for example, in Thailand, many of those smallholder farmers have grouped themselves or partnered themselves to form cooperatives where they can perform better. And apart from the infrastructure and the regulatory system, you also need to develop the skills, especially the digital skills, apart from all the soft skills that I think Dr. Ramachandra is going to explain to us much more in detail. And also the global system to promote entrepreneurship and innovation among the young brains, to provide them access to finance, provide them access to technologies. We have several, startup accelerators or funding venture capitals that are emerging globally. And it is good that most of the investment are focusing now also on the aquaculture sector. So this is very promising for the aquaculture sector. And for the digital transformation, we have several challenges, as I explained, the infrastructure deficiencies, where we need to develop new operating models, and the skill deficits, which is in fact a global issue. And we need to upskill or provide digital tools, skills on digital tools to professionals, integration of digital technologies, the cognitive technologies, the artificial intelligence, machine learning. And at the same time, we also need to tackle the governance issues to provide a continuous learning, as you know that the trends are always emerging, and we need to update the skills of people to cope up with these challenges. So to conclude, we know that the pandemic, we need the radical changes in the aquaculture sector, because the pandemic may end now or when, we don't know, but the aquaculture sector may not be the same. And we need to have the most radical technology enabled production systems. And the biggest challenge is to retain competitiveness and improve productivity, but at the same time, ensure environmental, economical, and social sustainability. So this is a big challenge we are going to face. And exercises like this, integrating researchers, industry, and academia. And in fact, we have a lot of things, a lot of responsibilities to do in this count. So how well we integrate the emerging digital technologies with a sustainable production model is something that is going to determine how well these technologies are going to be, persisting in the aquaculture or fisheries industry. And that is all from me. And thank you very much for your patient hearing.
Okay, thank you so much, Mr. Sarin, for your very interesting presentation. So it is clear from your presentation that we can rely on the aquaculture sector in providing enough food for the people around the world. And there are apparently there are many technologies which can support the aquaculture, and by applying those technology in aquaculture clearly will provide a maximum productivity in aquaculture and will possibly reduce the waste and prevent disease. So we have question for you. We already have question for you. Actually, this is for the all speaker, but I can ask this to you also. So there are questions from Ristiawan Nugroho. It's a tremendous and a very actual topic, but high technology will be a high risk to users. For example, system error, high-tech tools, lack of user, etc. So how do you suggest to face all of the difficulties by what? Okay, thank you. Please.
So is the question on for me?
Yes, it's actually for all speaker, but I'll ask you for first.
Yeah, I think it's we can't deny this fact, but because this is a big challenge for the small hold operations, and especially in acquiring the digital skills, this is a bit a problem, and we really need to get or harness the strengths of many people in this, especially with the support of the government, with the support of non-governmental organizations, extension agencies. So it should be a collective effort to support the smallholder farmers. In fact, many of these, right from the simple IoTs, I know that a few farms in Thailand who have, employed these, but finally they stopped. I mean, there are a lot of practical issues when it comes to the actual applications. So we really need to continuously work on this, do the research on this, especially with the continuous collection of field data. So this is something which is required, and I think by integration of several agencies together, we can do it because it's improving day by day.
Okay. Aika.
Yes, Mike.
I think unless we speak in the language of the small fish farm, and they can see the gain, and I think this is the key for me, is if I am, how much more product can I produce? In other words, if I take one step, what do I get? If I take the next step, what do I get? So if they can understand, if I improve very simple things using IoT, very simple system, I can move from 200 kilo an acre to 300, right? And they know they can't always know the profit because the price can change, right? So market can change, but productivity doesn't change. If you can show the gain on productivity, it's a generic global indicator. So it's better to talk productivity gain than to talk a price gain or profit gain, because those things, the business will make a decision to give it to the local families, to sell it in the local market. They decide, But we need this international benchmark data to show if we really want to start off with local farm, then locally manufactured feed with the best nutrition, what's the SOP? Can we manage the way that that's done correctly? What simple IoT manufactured locally by students from the areas that they want to implement become sustainable? Bringing an idea from a long way. We say in Scotland, an expert is someone who comes not from my city, but with slides. So we actually want people who can come, who understand catfish farming, who understand practically IoT, combined with the academic institute who can make it sustainable by providing the backup for the education. But we need practical people in business as well as the academic institute. all of our courses in the UK are led by, and when I say our governing body is industry actually guide the formation of the course. And then we make sure that what we deliver is actually within the confines of what industry want to do. And I think it's important, Salin and Ilham, and that we have demonstration centres in institutes that can be virtual, that are small scale, very small things that people can do, like the IoT system with the 3 sensors, which was built locally. Those things need to be made available everywhere. And all of the institutes should be sharing on a common productivity basis. This is what we've done. This is how much more fish we get. This is what it costs locally. It will be different in Thailand and India, but the productivity gain should be the same. So I hope these bigger projects by the World Bank or EU, they start to disseminate and involve the institutes much more. My argument with the World Bank has been that they don't actually give any of the funding to institutes. It tends to be the government and industry groups, and then the academic institutes don't get as much of the funding as they should. I think hopefully Dr. Ramachandra, Mangalore's much better connected to the World Bank because of Senatil, who's their director. But I think that big funding also needs to involve academic institutes to gather the information. We don't always need, it's good that we work with UNIDO, good that we work with FAO, but it's also good that the institutes get funding to do this themselves.
Okay, thank you, Mike. So basically, if I can conclude that, how to face the problem, we could highlight or show to the farmer how much the profit will be gained when using the IoT.
No, I cannot profit.
No?
I said productivity.
Okay. Yes, to increase the productivity. Yes,
yeah, because I think it's key that everyone gets. That's why we talk productivity, because a farmer can see whether he's growing a crop or whether he's growing the fish. If he sees he has another 100 kilo in the same unit area and not much more cost, then he can sell that fish or eat it. And I think the concern is they invest in high technology and they don't see the gain. I think farmers need to see, I do this, I get that. And when they've got the fish, it's up to them where they sell it, and then it's up to them what profit they make.
Yeah, thank you, Mike. I can also add that it can also contribute to the increase in price sometimes.
Yes.
This is continuously being integrated with the certification system and traceability. So the IoTs can really contribute to the triangulation of data to make it more sustainable, and that can add to a premium price for the product. This is being adopted in Thailand.
As a businessman, I'll speak as a businessman. The biggest gain that you'll get is if they organize the pond and they produce fish of the correct size and specification for the market, they'll get more money. Okay, so everyone thinks, well, we go for an organic certificate or a sustainability certificate. What the market wants is a fish this size, harvested at the right time to sell in the market. Okay. If they have lots of little fish, some really big fish, difficult for the stall, whether it's in Chittagong or whether it's in Cochin, the local market wants a fish that fits on the plate and sells for the family, or the retailer wants the same thing, and they'll pay more money. They will pay you more money for the fish because it meets the specification. On top of that, for the international market, you'll get money for certification, but the first thing that the farmer needs to do is manage his farm as a business to supply the market locally for the best price. And if you can sell the whole fish on the local market with no filleting as pangasius, then you'll make much more money if you try to fillet. So as a business guy, first of all, understand what the market wants, and then actually if they want regular a fish of that size, then you need to manage your small pond. I mean, even in different countries, you only have a small part of the pond. You might only have 10 square meter as a small farmer, that you've netted off in the pond that you're trying to grow. So, you know, even in a community system, it's about how you manage the area that you own. And this is a question to Salin from me. What would, I mean, if you said, if you're a unorganized small farm, how much productivity gain can they achieve if they start to do things in a better way? 100%, 200%, 300%. So if I'm a 200 kilogram per acre unit and I'm actually producing a shrimp, if we can start to talk to the farmer in kilos, then you'll actually start to get change.
Yeah, thank you, sir. Thank you, Mike. Because, for example, with the experience in Thailand, many of the new systems are also aimed at, more sustainability, bringing more sustainability in the production systems, like managing the waste. A lot of influence coming out from the system, and then how or what kind of management interventions that you do for enhancing the, treating the water, reusing the water. For example, in pond recirculating systems for shrimp, that is getting very popular, and getting all the effluents treated and get the water back to the pond. So there you really need to have the continuous monitoring of water quality to make sure that the system works. And there, for example, you can always achieve at least 30% enhancement or improvement in productivity.
Yes. And that's what the farm needs to know.
Yes.
If they say,
yes.
I grow 1 ton, I can now grow 1.3 ton, then they're happy.
Yeah.
But the other information is not interesting to them. Small farms, they just want to see more fish.
Okay, thank you.
Okay, AQUA, sorry.
Thank you, Mike, and thank you, Salin, Mr. Salin. So I think, is there any question for Mr. Salin? Actually, you can also ask in Bahasa, and then I'll try to translate your question. So either way, you can provide better for you. If not, so I can understand that Mr. Salin is going to have another meeting. So thank you, Mr. Salin, for your time. We won't hold you any more longer because we know that you have another meeting.
AQUA, can I ask,
yes.
Do we have a copy? Salin, did you share the presentation for the group?
Yes.
Yeah, yes.
Yes, actually, we are going to send the presentation by Google Drive along with the certificate. Yes. So thank you, Salin.
Yeah.
Thank you.
Yeah, my apologies for not being able to continue. I wish I could do it, but
thank you, Dr. Salin. Thank you so much.
Thank you so much.
Thank you, Dr. Salin. Bye.
Thank you so much. Okay, so before we continue, actually, we have two questions for Mike and Pak Ilham. Is it okay if I ask you, or
ask Ilham?
Need to continue another session?
Yes.
Yeah, no problem.
Mike. Okay, so Mike, there's one question for you, or two actually. So from Rico Wisnuwibowo. So for Mike, how to overcome the first generation of farmers to introduce the IoT technology? I think that you already answered that, but let me just ask you again. I think you can share your experience about it.
Yeah, I think the first thing that you need is information on existing performance, and I congratulate UNIDO on the work that Sudari has led on standard operating procedures. You need very simple SOP that actually says this is how you do the activity that you do, whether it's make the feed, what gain do we get if we make it locally, how does the fish grow. They understand. You can IoT, you can use a simple app that could do that, and many of the people, the younger people, 50% use the IoT, use the a communication system by phone anyway. So IoT doesn't need to be a totally integrated system. It's about using information. So if we can gain the information from the SOP, I give an example. In Turkey introduced 500,000 farmers to best practice information on how they handled producing a crop. Yeah. And that was free in year one. And the crop increase in productivity by doing the right things at the right time made a big difference to performance. In year two, 680,000 farmers paid for the service. Okay, so it can be communication systems that advise the farmer it's the right time now, drain your pond, clean your pond. It can be the right time now to check the quality, the genetic material, use your extension service, whatever. It needs to be simple and useful for the local community. So I don't know, like Sidari, I've worked in a number of countries, probably about 60 or 70, I think. So in those countries, you need to go and live in the area where people are actually doing things and spend time every day understanding what the issue is. You can't do it by virtual. You need to have an extension service that visits the area. And I think that's what's good about JFU. And I'm sure Dr. Ramachandra will say the same thing. This is about very practical skill, actually making sure that people are skilled in simple things that can make a difference to the farm, and then one step at a time. But the last point that Salin made was 30% increase in productivity for doing nothing more than managing the farm correctly. And that's in a very well managed farm. My estimate was 20 to 30%. I'd said if you already have a good system, I think you gain 20 or 30%. If you're an informal farmer, I think you can gain 500%. So I think that if you're producing 200 kilo, I think you can produce a ton. But you need to actually do this one step at a time.
Okay, thank you, Mike. So to make it short again, let's just continue another session. So ladies and gentlemen, next we have Dr. Ramachandra with his topic, skill development in fisheries. So without further ado, Dr. Ramachandra, the time is yours.
Good afternoon to all. Hope my slide is visible, right?
Yes.
Yeah?
Yes. Please.
Visible, right? Right.
Yes.
Thank you.
You might want to go to full screen, Ramachandra, at the minute you're showing. I think you can click full screen. Yeah.
Okay, right? Yeah.
Okay.
Yes.
Okay.
Yeah.
Thank you.
Thank you. Thank you very much. I first of all would like to thank Professor Mike Dillon, who took so much of pain to organize this particular program. And before webinar, he wanted to organize one seminar symposium in Bangalore in Karnataka, that is in India, in the month of June. Because of this COVID, we could not materialize. In the meantime, I had invited for our program, that is Golden Jubilee celebration of College of Fisheries, Mangaluru, which was scheduled in the month of March. It was on 12th of March, and from 13th onwards, it was declared holiday for the students in the college, followed by declare of, or I can say the lockdown of the whole world. We could not organize the program. However, I would like to just share some of the slides. The college, which started in the year 1969, completed 50 years, and the first fisheries college in India, it started. And we had a series of programs that we had conducted as part of Golden Jubilee celebration, followed by Guru Vandana, what we call the felicitation to our retired teachers and supporting staff. Quickly, I'll just show those few slides. This is our first fisheries college, which was started in the year 1969 under the University of Agricultural Sciences, Bengaluru, that is the Karnataka state in India. And it is located, the college is located in Mangaluru, the coastal belt of Karnataka, that is the west coast of India. And we have got the facilities for education, teaching, followed by research and the technology which are developed to be transferred to the end users, ultimately the extension activities. And we do also take some of the research even going on board the vessel to the Arabian Sea, that is the west coast of India. And as I said, the Guru Vandana program, the felicitation that we had uh, organized in the month of March, we had felicitated our retired directors, professors, teachers, and also the supporting staff. So these are few of the clippings that we had organized from the association called Alumni Association of College of Fisheries, Mangalore, that is now 40-year old. So 10 years after the establishment of college, this particular association was established. Right? Right. As I said, our college started in 1969. Just I'll give you overview about the college before I come in detail about the skill development, how actually this came into our mind to start the skill development programs in the field of fisheries as such, and other areas including aquaculture, post-harvest management, everything. And in fact, this is the second fisheries college in Japan. And as I said, it was under University of Agricultural Sciences. It was there under that university for almost 35 years. And for the last 16 years, this is functioning under Karnataka Veterinary Animal and Fisheries Sciences University. It is located about 900 kilometers away from Mangalore, that is Bidar. Ours is an institute where we give education to the students who complete their PUC or 12th standard. And we have got two campuses. One is main campus. The name of the campus is Matsya which is in Mangalore, and another campus is the technology wing, which is located about 6 kilometers away from the main campus. The major departments in the college are aquaculture, fisheries resource management, aquatic environment management, aquatic animal health management, fisheries economics, statistics, and extension at main campus, and two more departments located at technology wing, 6 kilometers away from the main campus, is fish processing technology and fishery engineering and technology. And we have got supporting unit, physical education, which is required, which is a mandate for the students who undergo this particular course. And this is a 4 years degree program. I think most of you know it's being offered since 1969, and the first master degree program came after 1973, and we have got 3 years doctoral degree in all the departments. And currently we are following 15 committee adopted syllabus for teaching undergraduate students. Of course, we have got PG program, both masters and PhD, having both coursework and the research work. The specialized laboratories that we are having in our college include fish nutrition, genetics and breeding, fish genetics and breeding, aquatic environment management, focusing mainly on the monitoring of the all types of water bodies, inland waters, marine, fisheries resources and management, post-harvest technology. We include fish processing and engineering, fisheries engineering, and we have got specialized laboratories such as cell culture, fish disease diagnosis, biotechnology and bioinformatics, microbiology and molecular biology, fishcraft technology. And we do have sufficient funding support from both international and national agencies, where we also carry out a research, and this research will be useful not only to the scientists, but also the outcome of the result is transferred to the end users ultimately, that our clients are the farmers. Fish farmers, of course, we do also focus on integrated farming system, wherein along with the fishes, we also focus on cattle farming, poultry farming, piggery, other agricultural and horticultural crops that we raise along with the integrated farming system that we take up. And as part of extension activities, we do conduct various types of training to transfer the technology to the department officials, extension functionaries, and also the farmers, not necessarily the fish farmers, even the agriculture and allied areas farmers who are very much interested in. And we do get phone calls on the various technologies and the problems that they are facing, all these things. So we do conduct the training programs, workshops, seminars, and we do give the radio talks, TV programs, and we also publish various types of the books which are handy and which will be useful for the farming communities, and also the public manuals, leaflets, bulletins, all these things. And we do conduct field exposure visits as part of all these activities, not only for the farming communities, even for the our students as well. And we do conduct an annual event to refresh the mind of the students as part of the cultural activities, what is called as Fishko festival, which is very famous in fact in Karnataka, that is in India. And the career opportunities for the students we do have in central government, Indian Council of Agricultural Research Institutes, various universities, agricultural and animal husbandry university, including fisheries university that we are looking for. And there are 3 fisheries universities in India already, and we are into this. And students also get the job even in the state government as assistant director of fisheries, those who complete just 4-year degree, and they will be the government in the surveys. And our graduates also get positions in the private sectors, both feed manufacturing companies, fish or the shrimp seed production hatcheries, farming system, fish processing centers, all these things. And also the graduates are into Indian Administrative Service, Indian Police Service, Karnataka Administrative Service, all these things. And those who don't want to work for the government, they have got their own ways to sustain their life by having the self-employment and the entrepreneurs. Self-employment, we talk most of the time, those who are unemployed, we say the jobless people. And those who have graduated, especially the female who sit at home, we call them as housewives. Here no more those who complete bachelor's of fisheries degree, gentlemen, or the independent consultant or the self-employed, and the ladies who are the homemakers instead of housewives, we call. Right. Let me come to the actual topic now. You know all that fisheries sector is a key allied segment of agricultural sector, and it has been growing fast and acquiring the status of a full-fledged industry in India. The need for knowledge upgradation and skill development for providing trained human resources to the industry is gaining tremendous focus. In fact, the Blue Revolution would provide employment to millions while feeding millions in India through various produce from the fisheries sector. Since skill development is the workforce in fisheries is critical, and Skill India mission would facilitate Blue Revolution through the flagship of Pradhan Mantri Kaushala Vikasa Yojana scheme. The National Skill Development Corporation, under the aegis of Ministry of Skill Development and Entrepreneurship, Government of India, has collaborated with industries, corporate houses, state government bodies, as well as other ministries to ensure its effective implementation. The Agricultural Skill Council of India works towards capacity building by bridging gaps and upgrading skills of farmers, wage workers, self-employed and extension workers engaged in organized or unorganized segments of agriculture and allied sector. India is the world's second largest producer of fish, next only to China, in the area of fish production. Besides being a major source of revenue, fisheries sector is increasingly contributing to the nutritional security of the country. Fishing is a major industry in India, employing over 14 million people along the coastline of 7.5 thousand kilometers, with total fish production is 10.07 metric tons, and this sector contributes 1.1% GDP and 5.5% of the agricultural GDP. One of the stalwarts who are working in the better position, and especially the National Fisheries Development Board, the head office is in Hyderabad in India, where the chief executive mainly dwelt upon the need for enhancing the employment opportunities and uplifting the traditional fisher folk families, several of which are living below the poverty line, as well as need of alignment. Total Skill Council India CEO says, as per his ideas, he has pointed out that the Skill Indian mission would be acting as an enabler to the Blue Revolution. However, Kerala University of Fisheries and Ocean Studies, which is the first fisheries university established about 8 years back, the Vice Chancellor has favored the extending the skilling programs even in the deep sea fishing. The priority areas for the action of the skill development programs, the high priority, which is known to be the crucial one, where the skills for immediate action include setting up structures to demonstrate, record, and promote the professionalization of the sector. The successful planning of small business, environmental management skills, risk management, scientific knowledge and technology transfer, and better ICT skills. Other high priority, which are not crucial, the skill needs are marketing, market analysis, planning and project management, disease identification and control, as well as practical conservation skill. Medium priority skill include public engagement, formal recognition of technical and para-professional roles, negotiation and influencing skills, as well as customer care, communication and communication skills. In the context of the innumerable opportunities which the fisheries sector hold, there is need for enhancing the skills of the fisheries workforce. The successful skill development in fisheries sector include prioritization of job roles for skill development, modernization of resources for skill development, designing of training curriculum for skill development, and monitoring and the course correction in skill development, and also the plans that is to be made should be systematic. The skill development in fisheries sector, which is a catalyst for the blue revelation in India, include the fisheries sector comprising both culture and the capture fisheries has shown a continuous growth of 5 to 6% over the years, and there is a awful need for skilling in this sector for doubling the production of farmers' income. The Prime Minister of India, Narendra Modi, has announced in the year 2018 saying that the farmers' income must be doubled by the end of 2022, and therefore it is a task for the scientists who are working in the various institutes, agricultural, fisheries, veterinary sciences institutes, extension education units, and also Krishi Vigyan Kendras. We are having more than 514 Krishi Vigyan Kendras in India who are focusing the doubling the farmers' income, and they are working very hard. Earlier, the fisheries and aquaculture industry was mostly traditional in nature, but nowadays it is advanced like anything that we talk about smart aquaculture rather than we talk about the smart production and the productivity. Aquaculture production and productivity is the need of the hour for any of the people who are working with the industries or the farming activities that they are taking up. It is very much required. In the last 2 or 3 decades, a lot of scientific and technical developments have taken place, giving it the commercial status, particularly in aquaculture, where new development have been taken place throughout the world, and that is required very much. So therefore, top job rules for skilling in fisheries and aquaculture sectors I have categorized into aquaculture and the capture fisheries. Basically, in aquaculture, you require the technician, aquaculture workers, farmers, hatchery manager, fish production manager, worker, fish, seed growers, shrimp farmers, technician, mariculture activities to take up operators, and also the technician which are required for various activities as far as the aquaculture is concerned. In capture fisheries, people who are very much required to look after the implementation of various activities. It could be pond aquaculture, cage aquaculture, and also the advanced aquaculture system. Marine fishermen are very much required because they are involved in capturing the fishes. They go into the sea, and sometimes they will be fishing for months together in the deep sea areas, and they catch the fish, they process it, and then they bring to the landing center for landing their production or the catch. Inland fishermen are very much required, so they are not only involved in the aquaculture, and also they are involved in capture fisheries, especially the larger water bodies, the rivers, reservoirs, and also the lakes where they take up the activities. Of course, the skill development is also required for the person who runs the fishing boats, or what we call captain, fishing boat deckhands, or the crewmen who are involved in operating the net, and also the hauling the net, all those things. So they should be given the trainings, though they learn from their elders and the ancestors, and they have been following, but the technical knowledge need to be transferred to these people who actually involved in capturing the fishes. And also very much important here is that they need to maintain the quality of the fish until it reaches to the plate of a common man. Fish fish boats maintenance and fishing boat mechanic and other supporters, all these are required. And the challenges in skilling in fisheries industries include the challenge to convert the mindset of the institutes and capacity building providers, indulge only in knowledge based theoretical learning with minimum focus on scales, lack quality trainers, infrastructure, and the environment for the long-term skill-based training is very much required. And at the same time, the trainers whom we are going to train, they should be the masters, and therefore training of trainers are very much required. Unless you give them how the fishermen or the farmers who are involved in the various activities, whether it is fish or the shrimp seed production, aquaculture activities, it could be a pond aquaculture, raceway aquaculture, or pen culture, or the cage culture in the deeper water bodies. Even the cage aquaculture system is being popular, is getting popular in India, especially in the reservoirs, and of course even in the lake also. The Department of Fisheries officials are doing it. His slide is visible?
Yes.
Yeah, right.
Okay. Thank you, Dr.
No,
Amachandra.
it's there. It's okay. One second.
Okay, thank you.
Now, with this beef wagons, we have got funding support to an extent of 5.75 crore from the Ministry of Urban Development, wherein in Karnataka we have got identified 7 smart cities. One is Mangaluru, Belagavi, Shivamogga, Hubli, Dharwad, Tumkuru, Davangere, and Bengaluru. Mangaluru has been identified one of the smartest cities where we from our college have made a proposal to establish the skill development center, and therefore Mangalore City Corporation makes a clarion call to Mangalore's responsible second second
Okay, so
second no the slide is
where's the slide?
Okay.
Okay.
Now okay, right? Yeah. So, what is this smart city Mangalore all about? The city Mangalore is the gateway of Karnataka, and it is one of the districts of the coastal Karnataka has been selected the smart city to be developed under the Ministry of Urban Development. As I said, now presently the Mangaluru Smart City Limited, which is under municipality or the city corporation, they are taking up in addition to the development of the roads, offices, bus stands, airports, all those things that they are doing, and hence they have given a funding support to establish this particular center that is coming up in our own campus. As I said, 6 kilometers away from this main campus, technology wing, the place called Hoige Bazaar, where this is coming up in a big way, and this was inaugurated by the Honorable Fisheries Minister, and we had a memorandum of understanding between the college on behalf of our university and the Mangalore Smart City Limited, and the Minister of Fisheries had laid down the founding stone to establish this center in the month of June, and it is being constructed, and in another 3 months this is going to be completed, and soon after it is completed we are going to conduct series of training program, and the objectives of this particular project is to establish the skill development in fisheries and safety training center, and the second objective is to promote or to impart skill development training in 8 identified areas of fisheries. We had submitted 15 areas where we can take up. So after a thorough dialogue between the college and the Mangalore Smart City Limited, we have identified 8 areas where we are going to give the training, and finally once established and the training is given, those who get trained, especially the unemployed youths in the field of fisheries, they can develop, they can start their own entrepreneurship, and they can become self-employed as well. So these are the top 15 skill development programs that is to be initiated in the field of fisheries. Number 1 being the aquarium fabrication, maintenance, and breeding of ornamental fishes. So this is very much required nowadays. Even the youths who are interested, they will take up these particular activities. Of course, growing or keeping the fish at home, in the film theaters, exhibition, museum, everywhere, everybody has seen. But the youths who keep the fish, they will not be having the technical knowledge how it is to be maintained, how the fish need to be maintained, how fish breeding can be taken up, how that can be propagated. At the same time, if the technology given to make the aquarium, so that the training can be given. So this is one of the areas that we are going to give. And the second one is plastic menace is the serious issue, especially in the coastal belt, where one need to be given how to minimize or completely reduce the usage of the plastic. And the third one is advanced technologies of fish drying by solar dryers, and thereby they can get better rewards. And the novelty of the aquaponic and the hydroponic and it is integrated with the kitchen gardenings and commercializations. About this already Dr. Salen has briefed about the aquaponic, and this will be taken up in the big way. And the fifth one is the preparation of various types of value added fish products, especially fish which is not fetching a better price in the market or in the landing center. Naturally, we take up that particular fish for various other productions like fish meal, all these things, or the poultry fish feed, making all these things. But at the same time, good fish, which could be a white meat or non-fatty fish or fatty fish, can be used for the preparation of various types of fishery products. To name a few: fish pickles, prawn pickles, fish cutlet, wafers, fish popper, chutney, shrimp chutney, all these things. So various other types of these can be made. And another one is hygienic handling of fish on board and landing center. As I was mentioning in the beginning, when the fishermen, they go for fishing on board, so they need to be trained how the quality of fish to be maintained until it is landed. Next one is conservation of mangroves in for fish nursery grounds. So this was a priority area that we had proposed, but finally they said not to take up this particular aspect. And next one is establishment of sewage fed fish culture system. So sewage fish culture system is another area where people who waste their usages. It could be domestic waste or the industrial or the factory waste, all those things that is going waste, how best that can be utilized and recycled for aquaculture activities. So there is one research center in West Bengal, which is under Indian Council of Agricultural Research. They are taking up these activities, utilization of sewage for aquaculture activities. Next one is high-tech methods of salting and drying of the fish. So fishermen are doing already, salting of the fish as a part of the preservatives and drying the fish, so that the dried product or the salted product, fish products, can be stored in a airtight packets, and that can be stored for more than 3 months. And this is one area, especially the fisherwomen who are doing these sort of activities. If the technology is given, and they will be benefited. And another important supervision of aquaculture mammals and the birds that we have not taken up during the current skill development activities. Next one is the improved fish processing and the storage. So this is very much required. There are good number of fish processing units all over the world. They are doing very systematically, but still the improved and the advanced technologies of fish processing, storage, marketing, and the shipment, all those things need to be given systematically. So therefore we have taken up this particular area. Utilization of fish waste and how this waste can be utilized for making the manure. How manure is useful for various agricultural productions, and also for horticultural crops that is being used, and what is the usage of all these things, and how the scientifically it will be benefited to the farming communities, thereby they can enhance their production. Another area where we are concentrating on giving training to the youths who are living in the coastal areas on scuba diving and the snorkeling. This is the area where people can be employed, and they can do this sort of activities, and it is useful for the tourists who visit to the shore areas or the beach areas. And next, modernization of the fishing boats, and also the net making. Even the net is made, though there are factories, good number of factories, that they are making different varieties of the net. The various types of the nets, such as fursin nets, trawl nets, gill nets, drag nets, cast nets, and various types of, even hook and line, pole and line. So many types of gears have been designs, and the training will be given, especially those youths, the housewives, and also the unemployed. They may be, the graduates or the school dropouts. For them, this will be useful so that they can take up their own activities. So, under each head, what are the syllabus to be covered? So everything is given. So I
Excuse
don't
me,
think it
Dr.
will be much.
Ramachandra. I'm sorry,
Yeah,
I'm sorry, sir, but our time
I
is
completed. Yeah,
yes.
completed. Yes.
Okay,
Okay.
thank you.
So future skill needs, the last slide, analysis of skills needs emphasize the requirement for business management, skills such as business planning, project management and risk management. And of course, there is a deliverable which is required for the sustainable intensification and precise farming, particularly in the face of issues around food security and growing global population. And the skilled trades are expected to decline in volume as the sector becomes increasingly professional, and therefore these skill development activities are very much required. So therefore, any project that we implement, that should be properly initiated, planned, executed, and finally it should be closed. And when we close it, it should be useful and it should be continued by the rest of the people who undergo the training. Thank you. Thank you very much.
Okay, thank you, Dr. Ramachandra, for the presentation. Now we have a very good information about fisheries in India and also in Mangalam. So actually, we have already have two questions, or three actually. So the first is, as we know, IoT can indeed provide the productivity of fisheries, providing the highly demand. This is from the Tegar Alif Suhati. So IoT can indeed provide improve the productivity of fisheries, providing the highly demanded feed for the world, and hopefully eliminating the famine around the world. So meanwhile, the poverty is also one of our world problem, while automation is also almost everywhere and keep increasing. The job field for aquaculture become narrowed down, and hence the unemployed is increasing. So how is IoT and aquaculture face this problem? Dr. Amachandra, please.
Yeah. See, now all sort of the technology that is being developed, it has been, talked about, the advanced technologies are very much required. So if it is to be transferred only, through various types of the workshop and systematic guidance to the, needy people, then only we can, achieve so that these IoT is useful for them and they can take up in their future career. Otherwise, it becomes, difficult unless they get tried. And most of the time, those who are taking up various activities, starting from aquaculture to the production or hatchery production, they always, look at the YouTubes. They say that, there is, biofloc technology, there is RAS system, all these things is being done. I want to take up, and can you just give a guidance over phone? So it is, very difficult to, give them, complete technology over phone unless they undergo training, at least intensive training they should undergo. Then only they can able to, implement, and then they can become successful, and definitely they can, earn more.
Thank you. So by training, we can face the problem. Okay. So next question is from Johanna from Rifaf. So Dr. Ramachandra, what kind of novelties of aquaponic system that you found, and is that easily used as well as applicable to other users?
See, aquaponic and the hydroponic are the technologies started very recently, and people are doing.
Yes.
For that, you don't require, large volume of the water or the sufficient land that we take up with agriculture or horticulture, or in the water itself in the pond culture or any other type of the system. The fisheries activities, even in the terrace of any of the house, there also you can take up. So thereby, in a limited area, you can take up these types of activities, and thereby one can definitely earn. And people are doing so, and we are going to, develop a model type of, aquaponic system very soon after this particular training center comes up. So, and then for the local people, we can give, and we also invite the experts who are involved in these activities so that they can train who are not having sufficient knowledge about these particular technologies.
Okay. So the last question for you, in terms of institution in India, who is execute the government policy program? Is it more the NGOs or the local government? And who are priority target of the society? Are they gender based or something? This is from Bu Umi Zakia.
Yeah. See, basically, it is from the central government, and in turn, they will have an agency, private agency, or the local agencies, as you said, even NGOs. But in this particular skill development area, that where we are, doing this particular training program, so here they have identified Mangaluru Smart City Limited. Similarly, in the different areas, different cities which are identified, the smart cities which is under city corporation limited, which comes, so they are taking up. So this is the agency that is taking up, and NGOs who can also tie up with the government agency to start up these kind of activities.
Okay, so basically this helped by several governments and agencies and also NGOs, right?
Correct.
Okay, thank you.
Thank you.
So I think there's no more question for you. So thank you, Dr. Ramachandra, for your time. It's our pleasure to have you for our speaker today. So next we have Professor Asti with her topic, plant extract for food safety and fish farming production. So Prof. Asti, the time is yours.
Yeah, thank you very much, Miss Ika. Can you help me to share my
PowerPoint? Okay, wait a minute.
Okay, thank you. Okay, thank you very much. The Honorable Mr. Sundari, Mr. Ilham, Prof. Mike, Dr. Ramachandra, Dr. Krishna, and Dr. Romi, my friend. And this time, I want to share about our research. Yeah, okay. Okay, thank you very much. First of all, I would like to send my thank you to the Jakarta Technical University Fisheries for inviting me to be speaker in this conference. And this time I will inform about our current research, plant extract application for food safety and fish farming production. And this is the simple research, but we hope can develop a drug for fisheries from the plant extract. I'm from Bulawarman University, East Borneo, and we have been developed tropical plant extract as natural drug fish to health management for almost 10 years. And the development research of natural fish drug production was registered on the Ministry of Marine Affairs and Fisheries and founded by some source, Bulawarman University, LPDP, Ristek Brin, and also Islamic Development Bank. Okay, next. And this is the several pattern upon the formulation and composition of herbal plant in East Kalimantan. And we know that the East Kalimantan or Borneo island has a many plant that can be developed to the antibacterial, immunostimulant, and feed addictive formula have been certified by intellectual property strike in Indonesia. And lately, I have joined with Indonesian Aquaculture Society with Mr. Romi and was elected as chief of business incubator, which responsible for developing potential research as a product and commercial technology, especially in the fisheries sector. Next. Now, I think the application of food safety in aquaculture production is very important. for the possibility of potential food hazard during the production, and potential hazard came from the contaminant with the veterinary drugs, hex stocking density, contaminant with pathogenic microbe from feces. Okay, next. And this is the last issue about the food safety in fish and crustaceans. In 1918, fisheries product accounted for 22% of the alert and 24% of the border rejection. The primary cause rejection notification were from fish. There are 467 total notification from a pathogenic microorganism, bed or infusion control, biocontaminant, heavy metal, and parasitic infection. Okay, next. Okay, and this is the corresponding with the Ministry of Marine Affairs and Fisheries in Indonesia. It might become one of the prerequisites of fish drug supposed to be safety, efficiency, and high quality. Safety not just for fish, but for human and for environment. Okay, next. And this is the sum of fish drug based of Directorate General of Aquaculture number 35, 2012 is one of the fish drug made by herbal plant and become one of opportunities for future research in Indonesia due to the variety and biodiversity in Indonesia herbal plant. Okay, next. Okay, therefore, all stake in aquaculture and its issue can be overcome by phytobiotic. Tropical plant extract contain various secondary metabolic, which has various functions such as a growth performance, antibacterial, immune enhancement, disease management, water quality control, air stress due to transportation or handling. Okay, next. Okay. Now, this is, I think, the crucial step of developing fish drug by herbal plant extraction was the selecting the raw material. We must selecting the raw material, yeah, the right material. Primary research will deeply help to discover a variety of plants that show the greatest effectivity for fish and shrimp. How the procedure, production, formulation method, and technical worksheet were adequately controlled by SNI or Indonesian National Standard. Okay, and this all required to obtain the result of research with high quality, safety, efficiency, and standard. And this is the step how we develop the fish drug from the plant extract. Okay, next. We have some plants that have many metabolic secondary compounds that can be developed the fish health management. I just explained the three of them. The first is lempuyang or Zingiberzerum bat. Zingiberzerum bat has a metabolic secondary component like alkaloid, flavonoid, steroid, and carbohydrate. And from the research, can inhibit the bacteria pathogen, especially Aromacydropila and then Vibrio harvey. Can enhancement fish immunity, can be anesthesia for fish transportation, and increasing the hatchability and hatching rate in batok fish. Okay, next. This is the Solanum ferox, or we call terong asam, especially fruit. Metabolic secondary compound like alkaloid, oligosaccharide, and peptine, and very good to be inhibit the bacteria pathogen, enhancement fish immunity, can be a symbiotic, improve the health and increasing growth rate in catfish and tilapia, mixed with lactobacillus casei, and positively modulating the good microbiota and for causing positive effect in the distal part of the colon. Okay, next. And the last is temu kunci, or Bosenbergia pandurata, has a many secondary component like alkaloid, flavonoid, carbohydrate, and steroid. Very good inhibit the bacteria pathogen, enhancement fish immunity, can be symbiotic to like terong asam, and can be adjuvant or adjuvant and immunostimulant, can be increasing the vaccination in fish. Okay, next. We try to develop the some product from the plant extract that the product made by 100% local plant extraction for aquaculture by different composition and concentration. Current test, we administration and obtain 5 innovation product from local herbal plant extract intended to different effect to fish, like biostasis, 3-in-1 bioimmune, phytoimmune, and biofit, and all have registered in KKP. Okay, next. This is the use of selenium ferroc extract on catfish concern a great improvement of survival rate or SR, and then specific growth rate, and then feed conversion ratio, and then it so that the use just 2 milliliter in 1 kilogram of feed on catfish can enhancement the catfish growth and performance. Okay, next. This is the mix on or concoction extract. Selenium ferroc and zingiberzerum that can be antibacterial drug for fish. The test on selenium ferroc and zingiberzerum that mixing extract as antibacterial effects show a great inhibit diameter until 20 until 21.7 millimeter compared with the tetracycline amount have 15 until 35 millimeter. And the survival rate after the challenges with the Aeromonas hydrophylla and Pseudomonas fluorescens pathogen bacteria showed a percentage of 84%. Okay, next. This is the antiviral activity of Bosenbergia pandurata single extract can inhibit the Aeromonas hydrophylla and Pseudomonas bacteria, and then combination bacteria or bottle bacteria very well. Okay, next. This is the disease management from plant extract for preventing the infection bacteria, that the test with administration to prevent the infection of bacteria. So 90% of fish uninfected by Aeromonas hydrophylla, and 100% fish free from Pseudomonas fluorescens after given by Bosenbergia pandurata. Okay, next. This is mixing zingiberzerumet and selenium ferroc with the vaccine to prevent from Aeromonas hydrophylla and Pseudomonas fluorescens infection. And from the research so that the mixing extract with the vaccine can increasing in the total leukocyte, in the phagocytic index, and then antibody production by fish. Okay, next. Okay, this is the total leukocyte increasing after vaccination with the mix with the extract. Okay, next. Now this so that the single extract then more better to increasing the phagocytic index than the mixing extract. Okay, next. And this is the adjuvant effect from the zingiberzerimbat and solanum ferox extract to number of mortality or RPS after infection with the Aeromonas hydrophylla and Pseudomonas florescens mixed infection. Okay, next. This very interesting that a water quality control. When we use the solanum ferox in aquarium or in fish tank, solanum ferox have antagonistic activity against a fungi, and solanum ferox inhibit to mycelial growth 77 until 82%, and spora germination until 80% saprolagnia, and application in fish tank can decrease of bacteria pathogen and fungi on 24 until 48 hour, and controlling the ammonia total in fish tank. Okay, next. This is the Bosenbergia pandurata and solanum ferox concoction or mixing in tiger shrimp, that it can confirm by the number of relativity present in tiger shrimp, that the use of Bosenbergia pandurata and solanum ferox as antibacterial solid SR among the 80%. Okay, next. And the single, okay, next. And the single extract of Bosenbergia pandurata mixing with the vaccine can help to improve the Pseudomonas vaccine perform in Nila tilapiae. This the antibody level can increase on 14 day after vaccination. Okay, next. And this is the relative percent survival of tilapia after challenging on day 7, day 14, and day 21 with the Aeromonas hydrophylla and Pseudomonas florescens, and the give of Bosenbergia pandurata extract can increasing the effectiveness from vaccine. Okay, or efficacy for vaccine. Okay, next. This is the one, our product. The last product is anesthesia for immersion anesthesia made by zingiberzerimbat, that using a zingiberzerimbat can make the fish like for transportation and for handling, that the effective fish decrease in caudal fin stroke in this is the time minute in minute, and the goldfish, pangasius, and catfish, that the pangasius is very sensitive with zingiberzerimbat, but all of it can recovery under 15 minute, 15 minutes after using the immersion anesthesia. Okay, next. This is the conclusion, that the plant extract, we have some extract can be developed, the drug for fish, like for disease management, for antibacterial and immunostimulant, can water quality control like flavonoid, alkaloid, and peptine, and then can enhancement growth like oligosaccharida, oligosaccharida, and galactooligosaccharide. And then the plant extract can be anesthesia for transportation and handling. I'm using zingiberzerimbat that has steroid and tannin, can be anesthesia for fish. And the last plant extract can be adjuvant, like a saponin steroid can be increasing or improving the efficacy of vaccine. Okay, next. Thank you very much. I think that all our new research about the plant extract in aquaculture. Thank you, Dr. Ika.
Okay, thank you, Professor Esti. Thank you so much. So based on your presentation, you have 5 products to be exact?
Yes.
Based on
No.
your research.
Okay.
Okay. Okay, so it's very interesting to know that various plant-derived product may have many benefit in aquaculture, and for example, for the growth performance, for antibacterial, for preventing disease in tilapia, stimulating immune response, and even control the water quality. So let's go on to the question. We have one question for you. So thanks. This is for Professor Esti. Thank you for a great presentation. I would like to ask you, how do we determine which natural ingredient that can be used as immunostimulant and antibacterial? And could all kind of natural ingredient be used for fish and shrimp also? Yes.
Okay, thank you very much, Dr. Eka. It's very interesting. Yeah, we have many plant extract can be developed the fish drug, and I think if we use the crude extract, it's very more effective because it's very cheap, and then the step is more short. Yeah, so we can develop more easy than we just choose the selective compound. And I think a fish has a simple what I can innate immunity. So some metabolic secondary can be effective to be antibacterial or immunostimulant, like alkaloid, flavonoid. There's some extract from plant or from fruit, from like what I can say, okay, rimpang. Yeah, rimpang has a many metabolic secondary can be. I think all of extract like alkaloid, flavonoid can be antibacterial and immunostimulant, and just I think I have explained about the how to step the plant extract from laboratory to the industry, that the has many critical step, yeah, to develop, and we must trying again,
yeah,
in our pond, maybe like
yes.
that, yeah.
Okay, so thank you. So basically, we have to use the crude extract, right,
Yeah.
from the plant, and basically we have to know the content of the alkanoid and flavonoid of the plant. Okay, next question. Whether the product can be used, this is from Almika Tasya, whether the product can be used in small fish farmer, and is it not harmful if it used continuously?
Okay, thank you very much. It's very safe, yeah, because we develop the fish drug from a plant extract, and like a jamu, yeah. People drinking a jamu every day, gitu, is not harmful and not dangerous for fish, and then for informant or for human. So we just selected the concentration and dose that the right dose to application in pond. But I think, yeah, we must move our aquaculture to just use the traditional or natural product from the local plant. And I think some of area has a specific plant extract can be developed the fish drug.
Yes. So I was aware that the plant itself has a unique component of the plant. So, but anyway, it's all of the drugs is already tested, right?
Yes. Mungkin for the critical step. I'm sorry, why my voice is very.
Yes, it's had some feedback, right?
Yeah. Okay. I think the all of the extract. I just okay. Can you hear, Dr. Ika?
Yes, yes,
You...
I can. Yes, I can hear it clearly.
It's very
okay.
clear.
Okay, thank you very much. Yes, I think in in office is different definition. Not all of extra can be in the fish or the shrimp.
Yes.
So must has a specific component like
Yes, yes, specific compound.
yes, specific component. The product I took from the single extract, but the other I combine with two extract and combine the two extract and another just one single extract because there are specific compound that more effective to the antibacterial, but not effective to growth the probiotic. So I think the critical point when from laboratory to industry, we must trying many place upon and then many condition because
Yes.
from that we can develop the new product and the more good just can try and one product from Bosenbergia pandurata and Solanum ferox or we call it a phytoimmune that the using with Mr. Sino and Mary for improving the immunostimulant in Panama.
Panama, yes. Okay, thank you. So another question. So we have only two questions left. Let me just restrict that into two questions because the time. So Professor, I've been developed a multivariate model for aqua productivity based on genetic. Would you tell me how much contribution in quantitative of fish health management contribution to increase aquaculture productivity in general or short way? Thank you.
Okay. I think thank you very much for Setiawan Nugroho from Universitas Diponegoro. I think health fish management is one of uh, uh, important thing in aquaculture because um, all of process all of process in aquaculture like from breeding and growing and then harvesting and then transportation is has or need a health management
Yes.
for what for safety, for safety not just for fish but for human
Yes, for human.
and we develop the some product to step in aquaculture from the breeding, how to get the larva or egg in fish and then how to increasing the growth and how to uh, what how to managing the water quality and how to maybe decrease the feed that we give in fish and then how to transport larva on or like indukan in another place with using the plant extract and when again I just say that many plant extract in Indonesia in Sumatra is Kalimantan can be developed the fish drug and we hope in the next year we not import the fish drug but we develop the fish drug with ourselves and many sector can be increasing with our project in fish drug. Maybe I can.
Okay, thank you, Professor Esti. So this is another question from our speakers, from Dr. Rama Chandra. He asked you, Professor Esti, could you briefly explain the extraction tips for in field so that it will be useful for the environmentalists?
Okay, thank you very much. This is the one point of step. Maybe I have process, but in video. May I show the video?
Yeah, okay.
Okay, no problem. Okay, white. Okay, white. I have the step process to develop the plant extract. Okay, white.
But perhaps, sorry, I'm so sorry, Professor. Perhaps in the brief way.
Oh, no, you let her show. Stop. Carry on, Esty.
Mike,
yes. Esty, please show.
Okay, then. Okay, Mike.
No problem.
Go, Esty.
Just Okay, I just want to show you the step ya.
Karena tanpa penggunaan pengawet itu biasanya daya tahannya tidak bisa mencapai.
Okay, this is the step extraction. We use big extraction. Ya,
Mikroba dalam produk dan juga bisa
how to use ya.
Untuk menanam tanaman rimpang lempuyang dan juga temu kunci serta buah terong asam jadi bahan baku dalam pembuatan obat ikan bioimun dan 3-in-1 bioimun. Selanjutnya setelah pemilihan rimpang dan buah pemotongan menggunakan mesin
automatic
pencacah supaya ukurannya sama sehingga tingkat kekeringannya juga sama. Kandungan airnya tingkat pengeringan yang dilakukan dengan menggunakan oven itu selama 48 jam sampai 72 jam hingga bahan memiliki kandungan air sebanyak 10%.
Okay, after that,
semua bahan metabolik yang diharapkan itu bisa keluar pada saat proses meserasi atau perendaman dengan.
Okay, after that we meserasi with the ethanol.
48 jam sampai 72 jam sampai warna etanol yang jernih itu menjadi warna kekuningan yang menandakan bahwa seluruh bahan metabolik sekunder dari kandungan bahan-bahan tersebut keluar. Selanjutnya prosesnya adalah ekstraksi dengan menggunakan mesin ekstraktor. Kami sudah tidak menggunakan lagi mesin ekstraktor yang ada di laboratorium dengan skala kecil, tapi sudah menggunakan skala besar yang berukuran 50 liter, sehingga proses ekstraksi itu memakan waktu yang cukup cepat. Untuk sekitar 25 liter itu memakan waktu 2 hari, ya, 25 liter sampai 50 liter itu memakan waktu 2 hari. Kemudian setelah menjadi ekstrak, kemudian dimatangkan di dalam oven sehingga memiliki tingkat vikositas 1000 sampai 1200.
Okay. And this is the mixing.
Nah, setelah itu dilanjutkan dengan proses pembuatan produk. Pengencer yang kita gunakan adalah Aquaculture yang sudah di steril ya sehingga memiliki kandungan mikroba yang rendah dengan menggunakan mesin filling dan pencampur yang semi otomatis. Nah, sampai produk siap dikemas dan juga dihantarkan sampai ke pembudidaya.
Okay, thank you, Dr. Ika.
So, may I just give you a small question? The machine itself, do you make it with yourself, or does it is a mass production machine to extract?
Mass production machine. We develop the mini industry from LPDP fund grant to both the industry and now we can produce until 500 bottles of bioimmune and all. And we have now in pandemic many people like cupang, ikan koi.
Yes, yes.
Yes, and the product is very interesting for people.
Is it sellable? I mean, is it already
No,
sold?
Aika,
Yes.
no time.
Mike, I'm curious also, Mike, come on. Prof. SD, forgive me and forgive Mike, okay? We are already used to this kind of conversation. Okay, then Mike, I'm not going to ask her anymore.
No, I'm teasing. Aika, you go.
So I'm just asking. So I'm just asking, Professor SD, is it this product? Did you sell it? Where do we can buy the product ourselves?
Yeah, the product can buy in Tokopedia, Shopee, Minapoli, and then we have a website bioimmune.com and biofit.id.
Okay,
it's very
so
cheap. Just 2,000, 30,000, just 30,000.
Okay, okay. So that's a good information about the drug. So we have another very last question for Omi. I'm not so sure that we could. I'm sorry. I think that we have no time. But Bumi, you could text Professor or everybody else if you have any further question. You could email Professor Esti. I'm sure that she will answer all of your questions. So Professor, thank you so much. It's a very interesting presentation. Thank you for time.
Thank you, Mike. Thank you, Dr.
Thank you, Prof.
Oh, thank you, Esti.
Thank you very much.
Okay, so ladies and gentlemen, let's welcome our very last speaker, Dr. Romi Noviadi. I'm very apologize for the waiting. So his presentation is recent technology applied in Indonesian shrimp farming industry. So without further ado, Dr. Romi, the time is yours. Dr. Romi?
Can you hear my voice clearly?
Yes, clear.
All right. Thank you, everyone. Thank you, Jakarta Technical University of Fisheries, for inviting me to this conference and for giving me the opportunity to talk about the recent technologies applied in Indonesian shrimp farming industry right now. So I would like to start my presentation with an overview about the global shrimp production by the Global Aquaculture Alliance right now. Is this coming from 2019, the survey data? So based on the goal surveys, the industry saw increasing trends. So the signs of recovery in 2016 and 2017 with the annual growth rate around 2%. So in global perspective, we know that the shrimp farming industry in the global perspective is showed an increasing trend. So this is a good news for shrimp farmers in the global worldwide. But if you look at more detail in the Southeast Asia regions, we also notice an increase in terms of the production quantity. However, even though there is a slightly decrease here in 2015, but overall at the end, the production has recovered since 2016 and potentially will increase into up to 4 million tons in 2022. This is the future challenge for Indonesian shrimp production system. Growth will be stronger in the Southeast Asian countries. And we noticed that Indonesia already set the ambitious target of increasing the country's shrimp export earnings by 250% by 2024. But we have to pay attention to our neighbor right now. Vietnam has a target of 10 billion shrimp export by 2025. It means that from 850,000 tons of shrimp during the 2017 into 2020, they would like to expand the production capacity up to 750,000 hectares with 1.15 million tons by 2035. Our close neighbor, such as Thailand and Malaysia, also focus on the production system right now. They now focus on the control of the ESPND and other disease infection, as well as improve the water quality for the culture environments. And do not also please pay attention to Philippines, because they also would like to increase the production, and they would like to be the top 10 of the shrimp global aquaculture producers in the next future years. So if we discuss and talking and also observe the current condition of shrimp farm in Indonesia, there's a tendency to move from the extensive system to the intensive system. So we know that from the picture, this is a good examples of the extensive system. They stock the shrimp directly from the sea, either partly or entirely, and relatively low, very low density and overlapping generation of shrimp. In the intensive culture system, they move to use the post larvae from the registered hatchery and free disease, and with a relatively high density. Even now the supra intensive, we know that our colleagues in Sulawesi, Dr. Hasanuddin Acho, even culture the shrimp more than 1,000 post larvae per square meter. This is a very huge achievement for Indonesia's shrimp farming industry. And we do not have any overlapping generation of shrimp in intensive culture system. So it means that when we move from the extensive to the intensive culture system, we involve several technologies here that we will talking in this presentation. So there are several technologies that have been involved in the Indonesian shrimp management system, either feed management system, there's a water management system, there's a biosecurity and culture system. And if we're talking about the feed management system, the shrimp farmers in Indonesia now tends towards the sustainable ingredients. It means that the diet must be developed based on sustainability, and plant-based protein source can replace the use of the animal meal. Several plant protein source that has been used and being applied in Indonesian shrimp farming industry right now. They use the soybean meal, the cottonseed meal, the corn protein, and canola meal. In the past, if you look at the data from 1990, around 69% of the diet formulation is coming from the animal meal, consists of the fish meal and poultry byproduct meal, and only 19% that coming from the plant ingredients. In the present, because of the systematic research and over the years, we can develop the diet formulation for shrimp production system. 53%, around 53% is coming from the plant ingredients, and only 31% is coming from the animal meal, and 16% is like a binders or minor ingredients. But in the future, we would like to increase more the inclusion level of the plant-based protein ingredients and reduce more the inclusion level of the animal meal. How to do this? We need to complement the plant-based ingredients with the novel ingredients, because we know that several plant protein source, they do not have any complete amino acid profile. Like a soybean meal, they have a low level in lysine, in methionine, and also corn probably high in lysine but low in methionine. But we need to complement them with the novel ingredients that can enhance the nutritional profile of the plant-based ingredients or plant-based protein source in the future. So we do have a research in Alabama in the Club Petit Mariculture Development Center. We replace the use of the fish meal here with the corn protein. We partially and also completely replace the use of the fish meal here with the corn protein. You see that the 15% is the reference in the shrimp diet formulation, either for commercial production system or for research system. And then we partially and completely replace the use of the fish meal with the corn protein. So in general, if we look at the amino acid profile of the feed, we do not have any significant difference, especially for lysine and methionine, because this is our primary concern when we try to replace the animal meal with the plant-based protein source. So if you look at the data here, 15%, 0%, with the proper diet formulation, proper blending between the corn protein and soybean meal, they do not have any significant difference in terms of the lysine and methionine. And if we look at the data, over 16 weeks of the culture period here, we do not have, statistically, we do not have any significant difference in terms of the final weight and yield, but we do have the difference in terms of the final feed cost and also the dollar per kilogram of shrimp. So we can see the data here. The price, the feed cost is reduced significantly from $700 to $500, and the dollar per kilogram is reduced significantly from $1.1 per kilogram of shrimp diet, from $1.6 to $1.1 per kilogram of shrimp diet. So this is a tremendous achievement. And nowadays, other than the use of the sustainable ingredients, because of the disease infection, because the white spot syndrome virus, yellow head disease virus, now the several farmers, I know the several farmers, and because I'm working together with them, we tend to move forwards to use the functional feed here. So this is the data that I use with the permission from Dr. Loktran, because we work together with the DDGS, the high protein DDGS. We challenge the shrimp with the ESPND, the Vibrio parahemolyticus strain of the ESPND, and we do see any difference in terms of the survival rate when we challenge them with the Vibrio parahemolyticus strain of ESPND. We feed them for 22 days, and then we challenge them for 1 day, and we observe the survival rate for 10 days. And based on the graph here, you can see that the diet that already include the high protein DDGS that contain with 25% yeast, they can increase the survival rate, because we know that the shrimp do not have any adaptive and innate immune system, but they do have the cellular and humoral response. And we need to prime them. We need to trigger the humoral and cellular response in order to increase the protection system against the disease infection. So this is become a straightforward future for shrimp farming industry. So the sustainable ingredients, if you already fix the ingredients, now the challenge is how we properly apply the ingredients into a proper feed management system. So in Indonesia, we know that there are several techniques for the feeding regime. There is a hand feeding system, or by using the automatic feeding system. But nowadays, several is a minority. It's not a majority. But I know the several farmers that already applied the sound-based feeding system. They use the hydrophone here to recognize the feeding, the need, the amount of feed that need by the shrimp, and they transform the decibel, the sound, to the amount of feed that can be dispersed to the pond. So this is what they call as a feeding the shrimp based on the need of the shrimp. So we have research also in the Alabama Development Center. In the Club Petit, we also analyze what is the difference between the hand feeding system, the automatic feeding system, and also the sound-based feeding system here. I just want to give you some idea and some brief conclusion here. If we look at the graph here, we can cut the production period by using the technology here. By using the sound-based feeding system, we can cut the production day from the more than 100 days to get the 26.5 gram per shrimp. We can cut into 90 days, and we get the better results with the average weight around 32.5 gram per shrimp. And we can increase the productivity of shrimp production. We can increase the efficiency. We can increase the effectivity of the shrimp production system. And also by using the technology, we can also increase the income for the farmers. And this is the graph when we compare two feeding system with the AQUA, the sound-based feeding system. So if we're talking about technology other than feed management system, we need to more focus on the water management system, especially for shrimp farming industry. And one of the primary concerns right now about the water management system is how to increase the level of the dissolved oxygen in the pond. So because this is a critical point in the culture environment for shrimp, there are a lot of innovations right now being performed and being applied and being developed by the farmers, including in my farm, we use the microbubble diffusers here, we use the injector venturi, and even use the more sophisticated technology that automatically turn on the paddle wheel when the dissolved oxygen is lower than the acceptable range. And this is like an automatic system to turn on the paddle wheel. So as the Dr. Krista Salin mentioned earlier about the use of the 4.0 technology, we also use the 4.0 technology in our culture system. We use the mobile apps that can sync the data cloud for easy access, and for service analytics for remote monitoring with notification and biomass estimation. I don't know, because I heard any feedbacks. I hope it's not disturbing you with the feedbacks also. All right, so regarding about the 4.0 technology, we already applied this system in our production system, and this is make us become more smart smarter and become more wisely to make a decision in terms of the culture production system. So because the data is properly stored and properly designed, and we can also make a good traceability of the data, and then we can make a decision to the culture system based on the data that we store in the application. So still on the water management system, right now there are so many concepts to stimulate the natural estuarine condition by creating the zooplankton blooms to the culture stream. And one of the concepts that being applied right now in the Indonesia stream farming system is the symbiotics culture system. Symbiotics means is the practice that involves the fermenting probiotics, generally rice bran and probiotics with enzymes and buffer in sterile waters. They trigger the bloom of the zooplankton. By doing this, the concept is to improve the pond environment condition. The symbiotic system that being applied, they claim that they can also increase the productivity. This is the before data and after data. And we can also see that the FCR is going down, the survival rate is going up, and the productivity is going up. So the benefit of the system, they can distribute the probiotic colonies and they control the disease, Vibrio and other pathogens, and also they improve the water quality. There are so many concepts right now, including the biofloc system that developed by Dr. Saki Samoka from the Texas A&M University, and now there is a revolutionary concept, the aqua mimicry, and also the mixotrophic concept in the shrimp culture production system. So technology also involved the biosecurity program. So this is really important to secure the production system from the disease infection. So right now, most of the farmer in Indonesia realize that the equipment is a good factor for disease transmission. So for handling the shrimp and tank maintenance should not be shared between the tanks, and food bed for everyone already being applied in several farms in Indonesia. And also the use of the SP upstream for stocking density and also free from disease, other disease is being considered by the shrimp farmers in Indonesia. And also nursery culture system. This is a two-phase of culture system now being become more popular, especially to overcome the problem with the ESPND and other disease infection. Because the several benefits can be obtained by the nursery culture system. We can increase the operational control and biosecurity. We can provide more precise feed management system, and we can also provide more control to the culture environment. But please pay attention that using this nursery culture system, because based on my experience, pay attention to the stocking density. We cannot stock with the higher density above the optimum carrying capacity of the nursery tanks, because this also will affect the growth performance of the shrimp when we stock them in the culture period in the grow-out ponds. And also please pay attention that build the nursery system not far away from the grow-out ponds, because we want to avoid the massive mortalities because of the stress condition during the transportation period. So in our production system in Batam, we built the nursery system is very close with our growth ponds that our technician just carry on the post larvae after we count them and then stock directly to the pond. So this is a very convenient way to have a very precise data about what is the stocking density in our production system. Right now, also about the technology, there is more popular about the millennial farming system. This is bring up by the millennial community that they build a commercial round pond with the several diameters. They integrate the production system with a very fancy technology, sophisticated technology, 4.0 technology, automatic feeder, water monitoring system, and all this system is integrated into one farming system, what they call as the millennial farming system. So this is a good way also for millennial generation to start to be entrepreneur for shrimp farming industry. And this is I would like not to say that easy to masterizing this technology, but this is a better way to culture the shrimp with the millennial farming system, because with the technology that you use during the culture production system, that you can easily access the data and then make a smart decision during the culture production period. I noticed there are two top challenges for Indonesian shrimp farm industry right now. First is the broodstock availability, and the second one is the disease. We know that Indonesia now has one private company that focus on the broodstock production, is a Global Gain Indonesia, and one of belong to the government. We know that from the survey that being performed by the Willem, our colleague William from Netherlands, they said that Indonesia need more than 200,000 broodstock in order to achieve the target, the ambitious target to increase the productivity up to 250% in 2024. But the reality right now, Indonesia only can produce less than 50,000 broodstock. So we need more facility. So with the future expansion, we need more access to disease-free broodstock facility. So this is a good first challenge for Indonesia farming industry. And the second challenge is how to control the disease infection during the culture period. There are a lot of technology right now being developed, the quorum sensing, the glucans, polyphenols, organic acid, epigenetics, probiotics, biofloc, heat shock protein. They work better in the laboratory scale, but the problem is how we transform this technology to the field trial, in the commercial scale. So this is the challenge. But my colleagues in the University Putra Malaysia, we work together with this quorum quenching stage, how we inhibit the communication among the bacteria, what we call as the quorum sensing, by using several substances. And we have a very promising results when we try to, probably next year we will like to apply the quorum sensing, the quorum quenching technology in our commercial ponds in order to inhibit the communication among the bacteria. And by doing this, we make a peace with the bacteria. We not challenge the bacteria. So we inhibit the communication among the bacteria. By doing this, we would like to enhance the survival rate. Even the bacteria is there in the pond, in the culture system, but we would like to inhibit the communication among them. So we would like also to minimize the disease infection to our shrimp in our culture pond. So as the conclusion of my presentation today, we know that technology has been identified as a driving factor to increase the productivity of shrimp production system in Indonesia. There's an urgent need to establish another captive breeding facilities to produce the specific pathogen-free, specific pathogen-resistant, and also specific pathogen-tolerant broodstock. And 4.0 technology can also increase the productivity, and this can become a part of strategy if Indonesia would like to increase the productivity up to 215%. And challenge on novel technology development to overcome the disease problem in Indonesia. This is become the conclusion of my presentation today. So thank you, Jakarta Fisheries Technical University for the time, and I hope you enjoy my presentation. Thank you.
Thank you, Dr. Romi, for your presentation. It's very interesting to know that how plant-based feed can substitute fish meal and resulting same FCR with the low-cost feed production, and it's so effective. And again, we learned that by combining the technology and aquaculture system in this term is feed and water management system can indeed increase the production, especially in shrimp culture. So we have question from Faridatun Amalia. So as we know, in this condition of the COVID-19 pandemic, the decline in export is beginning because the consumption of fish and shrimp has begun to decline. And this is one of the challenges for us. So my question are, what is our strategy in future so that productivity can be optimal in this current condition, especially for shrimp farming? And as a student, what is the most important role in to optimize it? Thank you.
Yeah, I think this pandemic situation is affect all the industrial sector. It's not only aquaculture, but we have to know that probably Professor Mike Dillon also can add something about this. During this pandemic situation, only the aquaculture sector that can survive, because this sector can provide the food for food security and so food for consumption. Sure. So the thing is, we know that there's a decreasing trend about the export value, the the income for the country, because there's some there's also some issue that the fisheries product also contain with the with the COVID-19 that can also spread to the human.
Yes.
But I think based on the the consumption level of the global population right now, we can see that the aquaculture sector can survive from this pandemic situation. And how to increase the consumption is how we trigger the people, especially local people, try to increase the seafood consumption per capita per year. So, and also for export, we as a producer also, I noticed also there is many offer like a demand from other countries like Singapore and Middle East. It's always coming to us asking about, hey, can you supply a shrimp to our country, because we need a several quantity of the shrimp. But the the good news thing is not all shrimp is accepted by the market. All shrimp that produce in Indonesia is accepted by the market, even either local market or export market. So the thing is, we do not have any remaining shrimp that we can sell to the other country. So I don't know. I also make a survey to the farmers. Hey, do you have a problem with this pandemic situation? Have you ever have a problem that you can not find a market to market your shrimp from your ponds? And then they said is no, because right now Indonesian consumption is have an increasing trend, and also the export value also still increase, and the farmers also never complain about this pandemic situation. I never heard about the shrimp that cannot absorb by the market, but the thing is the price is not to have a very promising price like in the past, but we're working on it, how to increase the price, how increase the profitability of the shrimp farming industry. And one way to increase the profitability is by using the better feed formulation, like use the plant-based protein source to replace the use of fish meal. Right now the fish meal, the price per ton is around $2,000 per metric tons. If we compare with the soybean meal, it's a 500 per metric tons. If we compare also with the corn protein, like a DDGS is lower, even like only $200 per metric tons. So if we want to increase the profitability of the shrimp production system, we need to reduce the cost of the feed. So yeah, Indonesia can play a role on that one.
Okay,
thank you.
So, thank you. So another question from Bu Umi Zakia. So Dr. Omi, when you said that the productivity increased as the systems was changed from 2 daily feed into automatic system, what about the feed itself? Do these 2 systems show different amount of feed amount given? It will be normal perhaps if the feed amount increased, then the productivity might increase as well, but doesn't it mean that it will be more efficient anymore?
So yeah, it's a very good question. Probably people misunderstanding about the use of the automatic feeding, especially for the sound-based feeding system. They think that they will feed the fin consistently. They will more feed per day compared to two hand feeding system, but actually it's not. It is like the same amount of feed that we use in the 2-hand feeding system, 2-day feeding system, but we adjust daily based on we just adjust daily based on the need of the shrimp. But the adjustment number is not like double like 100% or 200%. It's still in the acceptable range. But the thing is, we have to understand that the shrimp has a very short digestive system. The shrimp also they are grazer animal. They're continuous feeder. They tends to eat more after there is no feed. They need to feed again because the digestive tract is very short. It is important to us to pay attention to this behavior, and we feed the shrimp like more than like two-time feeding system, because two-time feeding system is very short and is not recommended for shrimp farming industry.
Yes. Okay, thank you. For another question from Mr. Sudadi Padwilo. So Dr. Romi, what is the main challenge for Indonesia to produce good quality and quantity shrimp broodstock? Thank you.
Yeah, the thing is, we have to know that this Vaname is not our endemic animal. It's coming from the South America. So in terms of the genetics diversity and also for to produce the very good quality, we need to work closely with our colleagues in South America. It is better to make a good connection to them, because we cannot produce the broodstock by our own self, because this is not our animal. This is a alien species for us. But we don't know they can replace the production of tiger shrimp in the past with this Vaname. So they expand aggressively, they expand massively in Southeast Asia, but because probably this is the most species that have a very high demand in the global perspective. So in order to get to produce a good quality broodstock with a good genetic system, we need to work closely with our colleague in South America. It's the technology, we can masterizing the technology, we can produce the broodstock, but to get a very good genetic diversity is not coming from our area. We should also work closely with our colleague in South America. Probably that's the best thing that I can answer.
Okay, thank you, Dr. Romi. Maybe this is going to be the last question for you. This is from Asahedi Umoro. Dr. Romi, would you explain more about the density, pieces per liter, carrying capacity, and target of day of culture in two-phase nursery pond that you have?
All right, so the carrying capacity, if we're talking about the carrying capacity in the nursery tank, we already set the optimum carrying capacity is not more than 10,000 post larvae per square meter. So the culture period is not more than 10 days. If we culture them, is more than 2 weeks. Our experience, like we have had experience using a post larvae that the average weight is more than 0.3 gram. It means that we culture the shrimp in the nursery tanks for more than 20 days. The average daily growth in the grow-out ponds is very small, and is significantly affect the growth performance of the shrimp, because I think it's the phenotypic of shrimp during the culture period in the nursery system has a significant impact to the growth performance of the shrimp. So we make a standard operational protocol for nursery system. For the carrying capacity, for the density is not more than 10,000 post larvae per square meter, and the culture period it should not more than the 2 weeks. So the average week is very short. Because the main purpose of the nursery system is we just want to control the feed, because this is a still baby. We cannot rely on the blind feeding system, because with the blind feeding system in the normal grow out pond, we can control, because some of the shrimp can have access to the food, but some of the shrimp cannot have the access to the food. So with the nursery tanks, we will make sure that all shrimp can have access to the feed, and then they can grow, and then also we can control the biosecurity program in the nursery tanks, so we can also minimize the disease infection in the early stage of the culture period. So we get the healthy shrimp, a very good growth performance of shrimp before we stock to the grow-out pond. So this is the benefit of the nursery system in the shrimp culture system.
Okay, thank you. Maybe that will be all for your session, Dr. Romi. I'm very sorry for the other participant that asked you some questions, but maybe they could email you somehow, and I'm sure that you will. I'm sure Mike stop smiling, and I'm sure that Dr. Romi will be happy to answer.
I'm going to ask a few questions, Aiko.
Okay.
I think first, congratulations to Romy and the other speakers. I think the quality of the information has been very high. The thing that interests me, Romy, one thing, because you've already provided a comparative data showing productivity increase, probably I think in productivity, the extra 3.5 ton and the example in productivity terms is significant in terms of what you gain. But even more important is the feed conversion ratio and the other indicators. So I think if there was standard data, Romy, it would be good to create a standard template of information that we feel that we need, so that when we talk to Thailand, or we talk to Peru, or we talk to other countries, we can ask the same questions on the same KPI. So for me, as a productivity person, if we've got the same benchmark, useful if we talk between the groups. The second issue for me is, I started my career with Unilever Research, and our interest was always on active ingredients in plants and how we use them in the business. Okay, what things that we could do. My own PhD was in it was in active ingredients and what we could actually do to increase cell health. So when you talk about the epigenome, the nutritional control, which a previous speaker also touched on plant material, I think Indonesia has a wealth of plant material whose medicinal benefits are not as well researched as they might be. And I think it's good that with the work that you're doing, maybe you collaborate with Estimor in terms of what things can be produced specifically, not by accident, but specifically for the target things that you're trying to control is active probiotic, because I think the science is poorly understood. So I think just as a comment for me as a productivity specialist, we've talked to World Fish earlier about having a group activity with different countries sharing data on performance to see what we think the best performance that can be achieved actually is. So as you've got India and Dr. Ramachandra with 31 other institutes in India, and you've actually got the other institutes through AIT as a network, it would be good to start to build a network of interested institutes who would be interested in sharing productivity data. I think in the past I've been in Peru and talked to the Peruvians. It would be good to actually get some South American involvement, as you say, in terms of the genetics side and what's possible or not. But I congratulate all of the speakers, I think from Dr. Ramachandra, Dr. Salin from ST, and from yourself. There's such a lot of good information there. I think it's how we use it. So for Ilham, I think for me, it's about how we follow this up. You've got such in the next session, I'm trying to involve Bangladesh in the Pangasius thing with some other Pangasius producers to look at other species, but we should not lose what we've actually got from today. So, Romy, it's a comment as well as a question. What do you think the real productivity optimal gain can be? I've seen 30% in one project, but if you added all of the technology up, what increase in productivity do you think that we'll get? So Romy, best productivity gain, and I'm going to come back to Esty on her health management system, because you were asked a question, Esty, on what your multivariate analysis would tell you the best gain would be when you added up all of the health management benefits, and we didn't get a distinct answer. All I want is 200%, 300%, 30%. And I think for Romy the same, if we add up all of the technologies from what we'd call an extensive farm moving to intensive, what would the gain be?
Yeah, that's a very good comments, Mike, because if we combine all of this technology, we're not only talking about the productivity also, Mike, but we're also talking about how efficient our production system. So how can we cut the production cost? There's also a significant factor that we can consider if we're talking about the application of this technology. But my last article that I sent to the Asia Pacific Aquaculture magazine, I combine this only two technology, like a water remote monitoring system and also with the injector, Venturi injector, being applied in our culture system compared to the one that not being applied the technology in the culture system. We can increase the productivity up to 20% with a similar stocking density, with similar culture periods, because we also apply the probiotic technology on all culture system. But if we focus on the effect of this two type of technology, we can increase the productivity up to 20%. That's the best estimation, because we make a quantitative description about the data, and at the end we come to the conclusion that the technology can also increase the productivity. But if we expect more percent on the productivity, it means that we need to to invest more on technology on the culture system. But as you know, also the shrimp they have their own optimal carrying capacity to have the optimum growth and also optimum survival in the culture system. Even though we provide a very sophisticated technology, but we have to realize that this is we dealing with the live animal. We're not dealing with the the animal that they do not have any like optimum growth rate, like optimum carrying capacity in the pond. So we have to pay attention to this also, Mike. The carrying capacity, even we can increase the carrying capacity by increasing the level of dissolved oxygen, by increasing the amount of supplemental feed. But at the end, they have the saturation level. They have a saturation level that we cannot increase more. They hit the wall. There's the final stakes of the carrying capacity. That's why in shrimp production system, yeah, is very important.
Romy, I'm going to stop it and say, look, I think the question is, if you take the extensive farm step by step to the farm where you've actually looked at 17.5 ton, where you're actually saying, well, if we're actually saying that the ton per hectare in your example moved to 17.5, where does it start with in extensive? A ton, 2 ton, 3 ton? So that you can say from the traditional extensive, you don't need to answer. If you want to answer it quickly now, then fine, because I've got the same question to Esty as a productivity specialist. That's what the farmer wants to know is, if I'm a small farmer, how far can I go before we actually get to 17.5 ton? It depends where they start.
Yeah, if we're talking about extensive, even this lower than like lower than 1 ton per hectare, because the stocking density is very extremely low.
Okay.
It's extremely
so now
low.
I know. So what I'm trying to say, Romy, is we can increase 1700%. So you know what I mean, or so it's a big jump. When we say 500%, people think we're crazy, but when you're actually saying for the community that want to move together to increase, if they can see that actually in Indonesia, Romy knows that we can do this, not some crazy guy from Glasgow or some other country, but somebody in my country can actually show our community in Surabaya, in Lampung, in wherever, that if we work with them, we can take this forward. And if you say for the effort, step by step, what each cost benefit is in each stage, then it's a really useful thing to do. And Esty can't run away because we've asked Esty, she's here. Esty, we've asked you what gain, because you've demonstrated the gain, but Esty also using these different interventions in the chain was actually showing what gain she would get. And I think we should tackle that, Esty, which is, I can see Esty's there not answering. So the question is it a 30%, 40%? What do we get for the investment? And by the way, Esty, my own background is plant research and active ingredients. I work on medicinal plants we work on ingredient extracts, and everything that you say, I totally agree. But what's the number for the farmer? What's the percentage gain?
Professor Asti, you are muted. So
Yeah,
Mike
you need
asked
to
you.
beat her. Now you catch her and ask her that question, yeah.
I don't think that Professor Asti is, Professor Asti, did you hear me? Do you hear me?
No, I don't think she is. Don't worry.
Okay.
Yeah,
Okay.
but Mike, probably I can also help Professor Esti to answer a question, because the herbal extract, the plant extract is also similar. Because if we're talking about shrimp, Mike, this is a different animals like other vertebrates like a marine fish or freshwater fish, because they do not have this adaptive and innate immune system, Mike. So it is like the application of herbal extract. This is also similar with the application of immunostimulants, the application of the probiotics in the culture system, just to want to trigger the response, the humoral response and cellular response on the shrimp. So the thing is, if you asking Professor Esti about how what is the percentage of the productivity increase by the application of this technology, I would say that this is not a very static data, Mike. The thing is why farmers doing this, just because there's a nightmare on their mind, because there is a disease infection and everything. But this is like a preventive strategy, Mike. It's not like a magic bullet that you can apply to increase the survival rate of the shrimp production system. But this is just a preventive approach. But based on my experience in the shrimp culture techniques, shrimp production system, either in laboratory scale or commercial scale, and this will contribute around 10% of the production cost. But if we apply this properly, and if we design this properly, we can also increase the productivity like a 20 to 25%. Still, there is a benefit by apply this type of technology, Mike, like plant extracts, herbal extracts, immunostimulants, and everything. But we have to pay attention to the to the behavior of the shrimp, how they grow, how they live, and how they survive in the culture environment.
Yeah, I agree, Romy. We've worked with probiotic and prebiotic with the manufacturers of the drug. But what's interesting is if you do it naturally in your country with the plant extract rather than actually buying in a commercial product. So I worked on live weight gain. We worked on all sorts of things on animal health. So it's interesting for me to see practically, can we do it in Indonesia? Can you work with estes so that you refine it? Because if you want to get into the genetic side, there's a lot of stuff that can be done with the plant extract to actually see what impact it has. So anyway, I leave it like that. I pass it back to AQUA. Okay, Ma.
Okay. Thank you, Mike. Thank you, Mike. So, ladies and gentlemen, before we end, thank you again. Sorry, thank you, Dr. Romy, for your presentation for today. So, ladies and gentlemen, before we end our main agenda in this webinar, let's hear some final remarks from the Jakarta Technical University of Fisheries Director, Mr. Ilham. The time is yours.
Okay, thank you, Ika. I just want to quickly express our thanks and gratitude to all speakers today. Dr. Ramachandran from College of Fisheries Mangalore, thank you very much for your nice presentation. I hope in the future we can collaborate. And Mike, please facilitate us to keep staying in touch with Dr. Ramachandran and his institution. Also, Dr. Salim, we've been working with Dr. Salim and IIT since 3 years ago, and now we still have ongoing projects. And Professor Esti, thank you so much for your time and availability today. Hopefully, in the future, Polytechnic AUP and Mula Warman University can have a collaborative project as well in aquaculture feed and nutrition, yeah, Pak Romi. I think, Bu Ika, our moderator today, is also our feed nutritionist at Polytechnic AUP. Myself is quite interested as well in feed and nutrition. So I have the same background with Pak Rudi, I think your college, Prof. And Dr. Romi, always enthusiastic and very interesting information available from you. Thank you for your data and information sharing today. And last but not least, Pak Sudari and Mike, thank you. So you're very, enthusiastic as well. You're showing your great interest. We know you love Indonesia so much, and you love to see the increase of our aquaculture and fishery productivity happening. Using like your benchmark, your KPIs, for all productivity indicators that has been applied successfully in other sectors. And now, as we always discuss, we would like to transform all these success story best practices into our aquaculture and fisheries productivity. And as I mentioned earlier, that in the future we have a big dream, to see the big mob from the lowest productivity sector to be at least, not at the lowest, but in the middle, like in the middle status, of the whole list of the sectors. So because we are, blessed with huge marine and fisheries resource potential, and we agree that in the future Indonesia should benefit from these resources. So again, thanks for all, Dr. Ramachandran, Professor ST, Dr. Romi, and Dr. Sudari, Prof. Mike, and all the committees and all the participants. Thank you for your time and availability. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Waalaikumsalam.
Okay, thank you, Mr. Ilham. Next, I will deliver it again to the host, which our MC today, Alfie, please.
Okay, thank you.
Aika, can I make one comment?
Yes, of course.
Dr. Ramachandra mentioned that we were due to have the World Productivity Congress in India in May, I think it was. So we hope we still have the World Productivity Congress will be scheduled. We have India, China, where we've actually agreed events when the COVID restrictions lift. The other thing is the next World Seafood Congress. We had IAFE visited. We're wanting to visit Dr. Ramachandra to celebrate his 1969 to this year birthday. But the first World Seafood Congress was also in 1969 in Halifax. Okay, so we hope that we can bring Dr. Ramachandra and the whole Indian network together for the next IAFE World Congress. We'll hold the next one in Portugal. The one after that will actually be in India. So we'll make sure that GFU is now a network partner in the Seafood World Congress. So we look forward to that happening. This report from this event will be sent to IAFE for publication in the Fish Inspector. And I think we should allow Sudari at UNIDO to say a few words. I want to thank UNIDO for facilitating the support for me to be involved in this, because this is my 40th year of being involved with Indonesia. So it's a long time. So maybe Sudari, I say thanks. We will carry this on in a future webinar event. Okay. So we'll be working with Ilham and UICA and Romy and some of the speakers about what the next productivity related aquaculture sector is that we hold a discussion on. But certainly South America, we should get involved, is what we've said. So I'll pass that back to Sudari now to say a few words.
Well, not really, well, Mike. I think it's thanks to everybody. Thank you, Mike, Dr. Ramachandra, and also Dr. Romi and Professor Resti for the contribution. I think it's very good. I think we are looking forward to further follow up on this webinar. And working with Pak Ilham, I think our program is based in STP, so we can always discuss and then how we can move forward from here. Thank you, Pak. Thank you.
Okay, thank you, Sudari. Ma'am, over to you.
Yes, thank you. So Alfie, please
Okay,
continue.
Mom. Okay, Mom. Okay, thank you, Ms. Rusika. Again, those were great presentation. And sadly, we're coming to the end of this webinar. Our Excellencies, distinguished speakers, ladies and gentlemen, we are really honored to have you here in this afternoon or evening maybe. We are really had a productive and inspiring time together, and I hope you found the presentation on this webinar are informative and helpful for you. So we will close this webinar. Let us all be guided by all the things we have learned and heard and be able to influence our future. And I hope we can meet in another good time of webinar. So thank you very much for joining us and good afternoon.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Thank you very much.
Baik, Dr. Sama. Baik. Pak Ilham. Sehat ya.
Thanks to
Dr. Romi,
Professor
thank
Mike
you.
for
Thank you.
well-planned webinar. Thank you.
Thank you.
Thank you very much. Thank you, sir. Thank you, sir. Thank you.
Good
luck.
Thank you.
Brawijaya, thank you.
Terima kasih Prof. Isti.
Oh, pasti.
Terima
kasih.
Oh, ada Pak Sino.
Terima kasih Dr. Ilham, Ibu Ika.
Ya,
Menyimak Prof.
Terima kasih banyak Pak Ilham.
Thank you. Namaste.
Prof. Isti, selamat, sukses.
Ya, Bumi, makasih ya.
Sama-sama. Sukses.
Selamat buat Pak Ilham.
Oh, siap.
Aika.
Terima kasih Ibu
Yes,
Ika.
Mike.
Terima
Can you
kasih
send
Ibu
Pasidari's presentation to the postgraduate group in the Young Samurai and highlight the theory of change slide that he's put up?
Okay.
Okay.
Okay, Mike.
Ramachandra, thanks again for coming.
Thank you, Professor Mike. Thank you all.
Dr. Ramachandra will email you about the recording.
Sure. Thank you.
Thank you.
Aika, okay, we won't
Bye.
sell you.
Bye.
Yes.
Not for sale.
No, you won't sell me now because
No, you're too expensive, yes.
She's
I'm so expensive now. I'll say goodbye now. Bye, Mike. Bye, Dr. Ramachandra. Bye, everybody. Thank you.